There is a city beneath the city, not metaphorically, not in the poetic sense that people sometimes use when they talk about layers of history buried under pavement and glass and the relentless forward motion of modern life. Literally, physically, a network of tunnels, passages, chambers, and hollow spaces discovered not by accident, not by some lucky worker swinging a pickaxe and breaking through to something unexpected, but by a battery of ground-penetrating radar surveys, LiDAR scans, and subsurface acoustic mapping tools that were never even invented 20 years ago. Tools so sensitive they can detect a cavity the size of a kitchen table, 30 meters below solid bedrock. Tools that, when aimed at the ground beneath three of Canada's oldest cities, started returning images that nobody in the survey teams knew how to explain. This story begins in the way most truly strange discoveries begin, quietly, bureaucratically, with a committee meeting and a budget allocation and a government contract to assess the structural integrity of aging municipal infrastructure in Quebec City, Montreal, and a third site that the preliminary reports refer to only as the Northern Survey Zone, a designation that has puzzled researchers because it does not correspond to any publicly listed infrastructure assessment project in the federal database. The official purpose of the survey was mundane. Cities built on centuries-old foundations develop voids. Water pipes corrode. Colonial-era cellars collapse inward and create subsidence risks under modern streets. Insurance actuaries want data. Engineers want data. Municipal planners want data. So they send down the machines, and the machines come back with data. Except in this case, the data came back wrong. Not wrong in the sense of malfunctioning equipment. Wrong in the sense that what the machines found did not match any geological model, any historical record, any engineering survey, any indigenous land use map, or any colonial-era archive that researchers have been able to locate in the months since the initial scan results were shared with a small group of specialists at 3 Canadian universities. If you are listening to this while you are trying to fall asleep, I want you to settle in. This is going to take a long time, not because the story is padded, or because I am going to waste your time with repetition, but because the evidence is layered in the way that all genuinely mysterious things are layered, and because to understand what the scans found, you first need to understand what should have been there, what the geology of that ground actually looks like, and why what turned up instead is so difficult to dismiss with easy explanations. I have spent a long time with this material. I have read the preliminary survey reports, the secondary academic commentary, the indigenous oral testimony that researchers began collecting after the initial findings were quietly circulated, and the historical documentation going back to the earliest French and British cartographers who mapped these territories in the 17th century. None of it adds up to a simple answer, but it all adds up to something. And that something is what I want to walk you through tonight, slowly, carefully, the way you would walk through a dark passage you had never entered before, moving your hands along the walls and paying attention to every detail. If you're watching this to fall asleep, that's exactly why I make these videos. Maybe subscribe and let me know where are you right now and what time is it. The St. Lawrence River has been carving itself through the rock of what is now the province of Quebec for roughly 10,000 years. Before that, the land was under ice, not a little ice. A continental glacier 2 kilometers thick in places, grinding the bedrock flat in some areas and leaving it fractured and pressure-riddled in others. When the ice retreated, it left behind a landscape that geologists describe as heavily jointed limestone and dolostone, underlain by older Precambrian rock, the kind of ancient deep basement stone that has not been meaningfully disturbed since the Cambrian period. The surface geology is well understood. It has been mapped, cored, sampled, and modelled for well over a century. There are no surprises in it. The karst processes that sometimes create natural cave systems in limestone terrain exist in this region, but they exist at known locations, in known configurations, and at scales that have been thoroughly characterized. When researchers say that what the new scans found cannot be explained by natural karst formation, they are not speaking loosely. They are speaking with the full weight of a century of geological survey behind them. What the machines found is not a cave. It is not a series of caves, it is a network, and networks, by definition, are designed. That word, designed, is the one that stops people. That is the word that makes archaeologists who have not personally reviewed the scan data reluctant to comment. That is the word that caused the initial survey team to run their data through 3 separate verification passes before forwarding it upstream. Because design implies intent, intent implies intelligence, and intelligence, at this depth, at this scale, in a region where the written historical record and the archaeological consensus both insist that no society existed with the capacity to undertake such construction before European contact in the 16th and 17th centuries, is not something that fits any model anyone has been trained to work within. Let me describe what the scans show as precisely as the available data allows. The primary tunnel feature runs roughly northwest to southeast beneath the old city core of Quebec, at depths ranging from 18 to 42 meters below the current surface. It is not perfectly straight. It curves. It has branches. At certain intervals along its length, the cross-sectional profile widens significantly, creating what the survey report describes as chamber-like expansions, roughly oval in plan, with ceiling heights, in some cases, exceeding 6 meters. The walls of these chambers, where the acoustic mapping has sufficient resolution to characterize the surface texture, show an unusual regularity. Not the rough, broken surface of natural dissolution, not the random faceting you get with water erosion, something closer to worked stone. The tunnel itself maintains a remarkably consistent bore diameter of approximately 3.5 meters along its primary run, varying only at the points where it branches or widens into a chamber. 3.5 meters. Wide enough to walk through with your arms partially extended. Wide enough, in fact, to move a loaded cart through. Wide enough to be, in engineering terms, deliberately functional. The branch tunnels are smaller. 2 of them run almost due north, toward the river. 1 runs east. The easternmost branch terminates in what the scan data shows as a large irregular void space that may be a chamber collapse or may be a feature. The survey equipment was not able to fully characterize at its current depth. The researchers who reviewed the secondary data have called this the terminus anomaly. They do not know what it is. They have 6 competing hypotheses, and none of them are comfortable with any of them. The Montreal findings are different in character, but similarly inexplicable. The subsurface network there is shallower, running between 8 and 20 meters below the current ground surface, and it is less linear in its organization. The tunnel axes in Montreal form something closer to a grid, or more precisely, something that resembles a grid that was interrupted or modified, with passages that begin confidently and then shift direction, or that connect to chambers from which no further tunnel continues, as if a plan was abandoned or a section was deliberately sealed. Archaeologists use the word blocked when they talk about tunnel features that end abruptly in solid stone, because sometimes ancient underground structures were intentionally closed, sealed. The question of what was being sealed in, or sealed out, is one that nobody in the current review group has been willing to speculate about in print. The Northern Survey Zone findings are the ones that generated the most internal debate before any of this information began to circulate outside the original team. The zone itself is in an area of boreal shield terrain, well north of the 2 major urban sites, and the discovery there was not part of the original infrastructure assessment mandate. It came from a supplementary scan ordered after a pattern in the Quebec City data suggested that the tunnel network might extend further than initially assumed. The team extended their survey corridor northward almost as a formality, expecting to see the anomalous features terminate at the geological boundary where the limestone gives way to harder Precambrian basement rock. Instead, the features continued. They changed character. The tunnel morphology shifted from the relatively smooth-walled, consistent diameter passages of the urban sites to something more irregular, deeper, and in at least 3 locations, apparently multi-level. 2 passages at different depths, running parallel, separated by a stone shelf or floor that the acoustic data suggests is between 0.5 meter and 1 meter thick. A passage above and a passage below, and between them, a floor. That is a floor. Floors are constructed. Floors are one of the most basic signatures of deliberate human modification of space that archaeology recognizes. To understand why this matters so profoundly, you need to understand what the official history of human presence in this part of North America actually says, and how recently that official history has begun to show very significant cracks. The standard account goes something like this. The St. Lawrence Valley and the territories surrounding it were home to various indigenous nations for thousands of years before European contact. The Haudenosaunee, sometimes called the Iroquois Confederacy, the Wendat, sometimes called the Huron, the Algonquin, the Innu, the Abenaki, the Maliseet. These peoples built longhouses and seasonal camps. They farmed, fished, traded, and maintained sophisticated diplomatic and political relationships across vast distances. Their cultures were rich and complex, and deeply rooted in the landscape. None of that is in dispute. What the standard account also says, however, is that these peoples did not build in stone at a scale that would have produced the features the new scans are showing. Longhouses were timber-framed. Village fortifications were wooden palisades. Underground structures, in the historical and archaeological record, are limited to storage pits, root cellars, and in some cultural contexts, ceremonial pits and semi-subterranean lodges. Nothing in the existing archaeological record for this region suggests tunnel construction. Nothing in the colonial era accounts from Champlain, Cartier, Champlain again on his return voyages, the Jesuits, or any other early European documenter of this landscape describes encountering or hearing about underground passages of any scale. And yet there is something else that the standard account has consistently struggled to accommodate. The oral traditions. Not all oral traditions. Not the full body of indigenous knowledge from this region, which is vast and varied and still actively transmitted, but specific oral traditions from specific communities that describe underground spaces in terms that have puzzled the researchers who have begun to pay attention to them in the context of the new scan data. The Haudenosaunee oral record contains references to what translators and cultural scholars describe as the world beneath the world, a network of passages and chambers known to certain lineages, used in certain periods for purposes that the tradition does not fully specify, but associates strongly with movement, with escape, with the preservation of knowledge and people during times of catastrophe. The Wendat oral tradition, which has been partially documented by anthropologists working in the late 19th and early 20th centuries, includes accounts of ancestors who travelled underground between places that are now separated by many kilometres of surface terrain, emerging at specific locations that are described with enough geographic specificity that researchers have been able to, in at least 2 cases, cross-reference the emergence points with locations that fall within or near the subsurface features the new scans have identified. This cross-referencing is preliminary. It has not been published in any peer-reviewed journal. The researchers involved are, understandably, cautious about making claims that they cannot yet support with ground truth data, meaning physical excavation or direct investigation of the features, which has not yet been authorized. But the correlation exists. The coordinates match within the margin of error expected when translating oral geographic description into modern cartographic terms. And that correlation is not something that can be easily explained away by coincidence, because the oral traditions in question predate the scan data by centuries, having been recorded in partial form by ethnographers who had no knowledge of and no interest in tunnel networks beneath Canadian cities. The question of who built what the scans are showing, and when, is the question that every researcher currently reviewing this data is dancing around, because the answer, whatever it turns out to be, is going to force a significant revision of something. Either the timeline of technologically capable human presence in this part of North America is wrong, and wrong by a margin that most mainstream archaeologists are not currently prepared to accept, or the oral traditions of the nations who have lived in this landscape for the longest time have been preserving accurate geographic and historical information about infrastructure that was built before the time period. Those traditions are usually assumed to cover, or both, or something else entirely, something that does not fit neatly into either the mainstream archaeological framework or the indigenous cultural memory framework, because it predates both of them. The Laurentide ice sheet retreated from the St. Lawrence Valley region in stages between approximately 13,000 and 10,000 years ago. In the final phases of glacial retreat, the landscape that is now Quebec City and Montreal was periodically flooded by the Champlain Sea, a large body of salt water that temporarily filled the lowlands as the land, freed from the weight of the ice, began its slow rebound. The Champlain Sea existed roughly between 13,000 and 9,000 years ago, By about 9,000 years before the present, the land had risen enough that the sea drained and the modern river system began to establish itself. What this means, in terms of human habitation, is that any structure built in the St. Lawrence lowlands would have needed to be built after 9,000 years ago to survive in any recognizable form. Before that, the area was either glaciated or submerged. So the window for pre-contact construction of the features the scans are showing runs from roughly 9,000 years ago to the 16th century, when European contact and documentation began. 9,000 years is a very long window, long enough, in principle, for the development of sophisticated engineering traditions that have left no other trace in the surface archaeological record, or that have left traces which have been found but misinterpreted, or that have left traces which have not yet been found because no one has been looking in the right places with the right tools. Ground-penetrating radar, capable of the kind of resolution the new surveys achieved, has only been widely deployed in archaeological contexts for about a decade. Before that, what lay below the frost line in urban centres was largely invisible. Cities built over potentially significant archaeology, effectively sealing it under layers of colonial and post-colonial construction, have only recently become legible to technology sensitive enough to see through those layers. The thought that the ground beneath Quebec City has been hiding something for this entire time, something that was there before the French arrived, before the British arrived, before anyone arrived who left written records, and that it has been hiding it in plain sight, below the streets that millions of people walk every day, is one that takes a moment to absorb. There is a man named Theodore Marchant who retired from the Geological Survey of Canada in 2009 after 31 years as a subsurface mapping specialist. He was not involved in the new survey. He was not part of the team that produced the scan data, but when the preliminary findings were shared with a small group of outside specialists in what was described as an informal review process, Marchant was one of the people who received the data package. His response, which has been described secondhand by two people who spoke with him directly, was not disbelief, it was recognition. He had seen, in the course of his long career, several instances of anomalous subsurface features in the Canadian Shield that had been logged and filed and never publicly discussed because they did not fit the geological models in use at the time. He believed, and apparently communicated this belief to the review group, that what the new scans were showing in the urban cores of Quebec City and Montreal was connected to something larger, something that the geological surveys of the mid-20th century had glimpsed at the edges of their capability and then lost because the technology to follow the thread did not yet exist. Marchant agreed to speak, briefly and on background, with one of the researchers coordinating the informal review. He said two things that have stuck with the people who heard them. The first was that the features in the scan data were too consistent to be geological in origin. He had spent 30 years looking at natural void spaces in rock, and natural void spaces do not maintain consistent diameter over distances of hundreds of meters. Natural voids expand, contract, bifurcate randomly, and terminate unpredictably. What the scans were showing was something that held its geometry, something engineered. The second thing Marchant said was that the depth profile of the network, the way the tunnel system descended gradually as it moved away from the river and then leveled off at a consistent depth beneath the Canadian Shield basement contact zone, was not consistent with any extraction or mining methodology he knew of from the historical period. It was consistent, he said, with a design intention. The tunnels were not following the ore. They were not following the water. They were going somewhere. He did not say where he thought they were going. He said he did not know. But the word he used for the profile of the network's depth behavior was purposeful. He said it looked purposeful. When a geologist with 3 decades of professional experience at the National Survey level uses the word purposeful to describe an underground feature in terrain, where human engineering of that scale has no place in any accepted chronology, it is worth paying careful attention to what he might mean. Not because retired government specialists are infallible, not because one person's reading of scan data settles any question, but because Theodore Marchant has spent more time looking at what the ground in this part of Canada actually looks like, from the inside, than almost anyone alive. And what he is describing is something that the ground was not supposed to contain. Let me take you back further, much further, to a time before any of the nations currently associated with this landscape existed in their present form, to a period in North American prehistory that is only now beginning to yield its secrets, and that may hold the context without which the tunnel network data simply cannot be understood. The Clovis first model of North American human prehistory, which held for most of the 20th century, stated that the first humans to enter the Americas arrived from Asia via the Bering Land Bridge, approximately 13,000 years ago. They were named for a distinctive stone point technology found at a site in New Mexico, and they were believed to be the ancestors of all subsequent indigenous American populations. The model was comfortable. It was supported by a significant body of evidence. It explained the distribution of stone tool traditions across the continent in a way that fit a straightforward colonization from the North narrative. And then it began to fall apart. Not all at once, slowly, site by site, date by date. Monteverde in Chile, where the archaeological evidence pushed human presence in South America back to at least 14,500 years ago, before the Clovis people could plausibly have reached that far south. Paisley Caves in Oregon, where human coprolites, fossilized feces, were dated to 14,300 years ago, again pre-Clovis. The Bluefish Caves in the Yukon, where cut-marked animal bones and possible stone tools have been dated to as early as 24,000 years ago, a date so far outside the Clovis window that many researchers resisted it for years before the methodology was sufficiently validated to force engagement. And then, most provocatively, the Cerruti Mastodon site in California, where a mastodon skeleton, found in the 1990s, was reanalyzed using new dating techniques and returned an age of 130,000 years, associated with what the researchers described as humanly modified bone, percussion damage patterns consistent with marrow extraction caused by stone hammerstones. 130,000 years, before the last ice age, before modern humans had left Africa, according to most models of human dispersal, the Cerruti site remains contested, but it does not remain dismissed. The point is not that any single alternative date is certainly correct. The point is that the Clovis first model has been replaced, in the current scientific consensus, with a model that accepts a much greater antiquity and diversity of human presence in the Americas. The question of how ancient, and through what routes, and with what level of technological sophistication, is genuinely open in ways it was not open 30 years ago. And when that question is genuinely open, the discovery of an engineered tunnel network beneath cities in the St. Lawrence Valley sits in a very different interpretive landscape than it would have if the old consensus was still holding. Who were the people capable of building something like what the scans are showing? That is the question. And the answer, or rather the range of possible answers, is where this story becomes almost impossible to contain within any single framework. There is a particular kind of knowledge that develops in cultures that live close to stone, close to it in the way that the people of the pre-contact street, Lawrence Valley, were close to stone, not as a building material in the familiar architectural sense, not as something you quarry and stack and mortar, but as a living presence in the landscape, as something with properties and behaviors and secrets that reward long attention. The Haudenosaunee word for stone, in several of the Six Nations languages, carries a connotation of memory, stone that remembers. The idea that stone holds time within it, that it preserves things, that it contains histories that other materials cannot hold, is one that appears across multiple indigenous North American traditions, in forms that vary but share this core. Stone does not forget. Researchers studying the oral traditions of the Wendat Nation have noted an interesting recurring motif in the creation and migration narratives that survive in fragmentary form from pre-contact periods. In these narratives, the land itself has an interior, not a metaphorical interior in the sense of spiritual depth, though that dimension is certainly present, but a literal interior, a beneath place. The stories describe ancestors who knew paths through the beneath place, who used them, who maintained them, who passed knowledge of them down in ways that were apparently quite specific, about certain geographic landmarks used as entry points, certain features used as navigation guides, certain rules about what could and could not be brought through the passages. The fact that oral traditions describe entry and exit points at specific geographic locations, and that at least two of those locations correspond with geographical coordinates that fall within the anomalous subsurface features identified by the new scans, is the detail that the researchers who are taking this material seriously, have found most difficult to explain as coincidence. You could argue, and some people have argued, in the preliminary discussions around this material, that the correlation is spurious, that the oral traditions are describing spiritual journeys through cosmological space, not physical travel through literal underground passages, and that reading them as physical geography is a category error, that the correspondence between the story coordinates and the scan features is the kind of apparent pattern that emerges whenever you overlay two sets of geographic data and look for matches, because with enough data points, you will always find some that align. These are fair arguments. They are the arguments that any careful researcher applies to correlations between oral tradition and physical archaeology. The problem is that in this case, the correspondence is not incidental, it is structural. The oral tradition does not just describe underground space in the general vicinity of the scan anomalies. It describes underground space that is organized in ways that match the scan data in detail, passages that branch, chambers that expand, movement that goes toward the river, movement that goes away from the river, spaces where the air changes, spaces where sound behaves differently. These are the kinds of specific, sensory, experiential descriptions that you get from people who have actually been somewhere, not from people who are metaphorically describing a cosmological concept. The limestone question is one of the most technically interesting threads in this entire story. The bedrock beneath Quebec City and Montreal is, as I said earlier, primarily Ordovician limestone and dolostone overlying older Precambrian basement. Limestone is the material in which cave systems most commonly develop through natural karst processes, and the St. Lawrence Valley does have some natural karst features, sinkholes, springs, and small natural caves that have been known and documented for a long time. The question the survey team faced after their initial scan was whether the features they were seeing could be explained as unusually regular natural karst that happened to develop in linear, branching patterns with consistent bore diameters, rather than the more chaotic geometries typical of dissolution caves. They brought in a karst geomorphologist named Isabelle Fontaine, who works at the Université de Montréal and who has spent 20 years studying limestone cave development across Quebec. Her assessment of the scan data, delivered in a written communication to the survey team that has been shared in confidence with the review group, was unequivocal. What the scans are showing is not karst, natural dissolution caves in this limestone formation. Fontaine wrote, "Follow fracture networks in the rock. They follow the bedding planes. They expand where the rock is weakest, and they contract where it is strongest. They do not maintain consistent bore diameters, because the dissolution process is controlled by rock chemistry and structure, not by any external design requirement. What the scans are showing follows none of these principles. The features maintain their diameter across geological boundaries, across changes in rock chemistry, across fracture zones where any natural cavity would expand dramatically. They cross fracture zones," Fontaine wrote, "as if the fracture zones were not there. That is not geologically possible for a natural void. Something with the ability to choose its path through the rock created these features." She did not specify what that something was, but she was definitive that it was not water. The tools available for excavating limestone in the pre-contact period are one of the threads that makes this story technically complicated. Stone tools can cut limestone. This is not in dispute. Flint, chert, and obsidian tools are harder than the limestone formations in this region, and sustained effort with such tools can absolutely remove material from a limestone surface. What changes the equation is scale and time. To excavate a tunnel, 3.5 meters in diameter, through solid limestone to a depth of 42 meters below the surface, over a horizontal distance of several kilometers, using stone tools, is a project of immense labor. Immense but not impossible, provided the labor force is large enough and the time available is long enough. The tunnel builders who created the Kharez systems of Iran, the underground aqueducts of North Africa, the hypogea of Malta, all of these projects required sustained communal labor over periods of years or decades. None of them required metal tools. All of them required organizational capacity, technical knowledge, motivation, and time. None of those things require a level of societal complexity that is, in principle, impossible in pre-contact North America. The labor mathematics are actually not as daunting as they first appear. A team of 20 experienced workers, working in shifts to allow continuous progress, could advance a tunnel through limestone at a rate of perhaps 1 meter per day using stone tools, fire-setting techniques for thermal fracturing, and water. Over a century, with generational continuity of the workforce and the knowledge, such a team could produce the primary tunnel feature visible in the Quebec City scans. Over 2 centuries, the branching system and chambers. This is not speculation. It is arithmetic based on well-documented rates of pre-industrial underground excavation from cultures around the world. What it requires is not technology beyond the reach of pre-contact North American peoples. What it requires is intention sustained across time. A community that decided this was worth doing and kept deciding so for longer than any single person's lifetime. The analogy that keeps occurring to researchers looking at the scan data is to Cahokia, the city at the confluence of the Missouri and Mississippi rivers that reached its peak between 1050 and 1200 of the Common Era, and that at its height housed between 10,000 and 20,000 people, and featured the construction of Monk's Mound, the largest pre-Columbian earthwork north of Mexico, an earthwork requiring the movement of approximately 22 million cubic feet of earth over a period of perhaps 2 centuries. The people who built Cahokia did not have metal tools. They did not have draft animals. They did not have the wheel. They had baskets, wooden spades, and an organizational system sophisticated enough to coordinate labor on a scale that most European cities of the same period could not match. And they did it. The mound is there. You can stand on it. You can walk its length and stand at its summit and look out over the Mississippi floodplain and understand, viscerally, what sustained collective intention can achieve without any of the technological assistance that modern people assume is necessary for large-scale construction. If Cahokia, then why not a tunnel network in the limestone beneath the St. Lawrence Valley? Not the same people, not the same culture, not the same time period necessarily, but the same human capacity expressed in a different medium, in a different geography, for reasons we do not yet understand. This is the question, not whether it was possible, it was possible. The question is who, and when, and why. The why is, in some ways, the most interesting dimension of this story. Tunnels serve purposes. Every tunnel ever built served a purpose, because tunneling through rock is difficult enough that no community sustains the effort without a compelling reason. The categories of purpose that tunnels have historically served are not mysterious: movement, storage, refuge, water management, ritual, burial. These are the reasons underground space gets created deliberately across human cultures, and the configuration of what the scans are showing suggests that movement was the primary intention. The main tunnel runs between 2 points. It connects something to something else. The chamber expansions along its route suggest waypoints, stopping places, spaces where something happened in transit. The branch tunnels reach toward the river, which would be consistent with either water management, access to a concealed river landing, or a connection between the main passage and some surface feature that is no longer present or has not been identified. The refuge hypothesis is one that several researchers have found compelling in the context of what is known about the history of conflict and displacement in the pre-contact St. Lawrence Valley. The oral traditions of multiple nations describe periods of catastrophic violence, of cities destroyed and peoples dispersed, of migrations undertaken under duress over vast distances. The Haudenosaunee oral record describes episodes of such severity that the nations were nearly extinguished before the formation of the Confederacy, which was itself created as a response to an era of devastating interconfederate violence. If underground passage networks existed in this landscape, they would have been invaluable as refuge routes, not defensive fortifications. Something more like escape infrastructure, the kind of thing you build not because you expect to use it every generation, but because the memory of what happens when you have nowhere to go is fresh enough that you decide to make sure somewhere to go always exists. The storage hypothesis is less dramatic, but perhaps more practically significant. The climate of the St. Lawrence Valley is severe. Winters are long and cold and punishing. The ability to maintain subsurface food storage at the consistent temperatures that underground spaces provide, typically just above freezing in this geology at the depths in question, would have been enormously valuable to any year-round community in this region. Large communities. Communities that were farming the broad river terraces and producing grain harvests significant enough to require storage at a scale beyond what any surface structure could protect from fire, flood, rodents, and the violence of other groups who might want to take what had been stored. The ritual hypothesis connects most directly to the oral traditions already discussed, and it is probably the least dismissible of the available explanations, not because it is easier to prove, but because the evidence for the ritual use of underground space by cultures across the Americas is overwhelming. From the cenotes of the Maya, which were sites of sacrifice and cosmological significance, to the kivas of the ancestral Puebloans, which were semi-subterranean ceremonial structures representing the Sipapu, the portal through which life emerged from the underworld, to the sacred caves of the Aztec, the theme of underground space, as cosmologically significant, as connected to origins and to the passage of souls, and to the access of powers not available on the surface, is one of the most consistent features of pre-Columbian American spiritual traditions. If the tunnel network was built in part for ritual purposes, this would explain some of the features that are harder to account for on purely functional grounds. The consistent bore diameter, which is more important for aesthetic or symbolic purposes than for purely utilitarian movement. The chamber expansions at regular intervals, which are more suggestive of gathering space than of simple throughput. The depth profile, which reaches its maximum depth at points that may correspond to cosmologically significant relationships with the bedrock below. And then there is something that none of the functional explanations fully accounts for, something that the survey team noted in their secondary data analysis, and then, apparently, decided not to prominently feature in their preliminary report. Something that was only brought to the attention of the wider review group through a secondary communication from one of the acoustic mapping specialists who felt it was being underemphasized. The acoustic data shows, at 3 points along the primary tunnel feature in the Quebec City scan, evidence of what the specialist describes as deliberate surface treatment on the interior walls. Not the smoothing consistent with sustained human traffic, which would produce a certain signature, but something that looks more like intentional application of material to the stone surface, a coating, applied not to waterproof or to strengthen, but for reasons that the acoustic data alone cannot determine, because acoustic mapping can tell you that a surface has been treated, but cannot tell you with what or to what purpose. When you put all of this together, what you have is a picture of something that was built, was used, was perhaps known about by the peoples who came after it was built, was encoded in traditions that preserved memory of it across centuries or millennia, and then was buried first by time, and then by the cities of the colonial period, until machines sensitive enough to see through all of that accumulation were finally aimed at the ground and came back with data that nobody knew how to explain. That is the structure of this mystery. And we have not yet begun to talk about the most puzzling piece of evidence. The feature that the scan team found not in the tunnel itself, but in the chamber at the northern terminus of the primary passage. The northern terminus chamber is the feature that ends most conversations about this data, because it is the feature for which nobody has a comfortable explanation, including the people who are most committed to finding conventional ones. The chamber itself is not dramatically large. The scan data suggests a space roughly 12 meters across at its widest point, with a ceiling height of approximately 4.5 meters and a floor surface that is, at most points, unusually level. Unusually level for a natural void. Suspiciously level, one might say, for a chamber that has been sealed beneath 42 meters of rock for an unknown period of time. The floor is not flat in the manner of a dressed stone floor. It is flat in the manner of a surface that has been worked to remove the natural irregularity of the bedrock and then, apparently, covered with something that the acoustic mapping reads as distinct from the native limestone in its density and reflective properties. But none of that is the detail that stopped the conversation. The detail that stopped the conversation is a return signal near the center of the chamber floor that the acoustic equipment characterized as a discrete object, not a geological feature, not a secondary void, an object, an artifact-scale return, in the terminology of the acoustic mapping specialists, which means a solid feature with dimensions consistent with something that was placed there rather than formed there. The acoustic data is not high resolution enough to characterize the shape of the object precisely, but the return is sufficiently clear to establish that it is not rock. It is denser than the surrounding limestone, significantly denser, and it occupies a position near the geometric center of the chamber floor, that is, in the judgment of every specialist who has reviewed the data, not consistent with random geological deposition. There is an artifact in the northern terminus chamber, or something that produces a sensor return, indistinguishable from an artifact. Nobody knows what it is. Nobody has been able to get closer to it than the scan data allows, because the chamber has not been excavated, has not been entered, has not been physically investigated at all. It sits there, 42 meters below the surface of the Canadian Shield, in a space that appears to have been intentionally constructed and sealed, in a tunnel network that should not exist and cannot be explained by any geological or historical model currently in use, and it waits. The question of why excavation has not been authorized is one of the most opaque aspects of this entire situation. The standard explanation offered by those with access to the institutional context is bureaucratic. Excavation beneath urban infrastructure is complicated. It requires permits from multiple levels of government. It requires coordination between federal and provincial heritage authorities, between municipal engineering departments concerned about the structural implications of underground investigation near existing infrastructure, between indigenous nations who may have a legal interest in any heritage features found in the territory, and between academic institutions who want to ensure that any investigation meets professional archaeological standards. This is all true. Urban archaeology is complicated everywhere, and Canada has specific regulatory frameworks for heritage protection that add additional layers of complexity. But the bureaucratic explanation, while accurate, does not fully account for the fact that the investigation has not advanced perceptibly in the period since the initial scan data was produced and circulated to the review group. Things that governments want to investigate get investigated. Things that face genuine regulatory obstacles can usually be expedited when the political will exists. The absence of visible progress suggests either that the political will does not exist, or that the obstacles are not purely regulatory, or that something about this situation is being managed in a way that is not reflected in the public record. The researcher who shared the acoustic specialist's communication with the broader review group, and who has been one of the primary points of contact for the small number of journalists and independent researchers who have begun circling this story, said something in a private exchange that was later described to me as characterizing the institutional response to the scan data in terms that she did not expect to use when she began working on this. She said that the response had the texture of something being managed rather than investigated. Managed carefully by people who were not behaving as if they were unsure what the data meant, but rather as if they were very sure what the data meant and were uncertain what to do about it. She said she had never encountered that texture before in her professional experience, and she was not sure what to make of it, except that it was different from the normal dynamics of a genuinely puzzling discovery. This kind of texture, this quality of careful management rather than genuine inquiry, is something that appears repeatedly in the histories of anomalous discoveries in North American archaeology. Not always, not in every case, but often enough that it has its own literature, its own community of researchers who have documented the pattern, and its own explanation, which is not necessarily conspiratorial, but is certainly institutional. The history of American and Canadian archaeology includes a long tradition of discoveries that challenged the established timeline of human presence and capability on this continent, being met with institutional resistance that was not primarily scientific in character. Researchers have documented cases where artifacts of anomalous age or technological sophistication were found, reported, debated, and then removed from the archaeological record by means ranging from simple reclassification to the physical relocation of specimens to storage in locations where they are effectively inaccessible for further study. The Smithsonian Institution, in particular, has been the subject of credible scholarly criticism for its handling of certain prehistoric finds that did not fit the narrative it was invested in maintaining. The argument is not that there is a conspiracy to suppress knowledge of pre-Columbian North American civilization. The argument is simpler and less dramatic than that. The argument is that institutions, like all social organisms, are resistant to information that would require them to fundamentally restructure their understanding of something they have built, programs and curricula and career frameworks and funding streams around. When the established timeline of human presence in North America was used as the foundation for a century of archaeological methodology, publication practice, museum curation, textbook writing, and graduate training, the institutional cost of revising that timeline substantially is not merely academic, it is structural. It requires rewriting curricula, reclassifying museum collections, revisiting the methodology of hundreds of published studies, and acknowledging that the tools and frameworks that shaped a professional consensus were not adequate to the actual complexity of the past they were purporting to describe. That is a very difficult thing for any institution to do. And so there is a tendency, documented not with malice but with sociological precision, for institutions to delay engagement with anomalous data, to apply more stringent standards of proof to findings that challenge the consensus than to findings that confirm it, and to frame any revision of the established understanding in terms as limited as possible, accepting only as much change as the specific evidence absolutely requires, and no more. In this context, the management, rather than investigation texture, described by the researcher familiar with the institutional response to the Canadian scan data, is not surprising. It is, if anything, predictable, which does not mean that the institutional response is wrong in every particular. Standards of evidence matter. Extraordinary claims require extraordinary evidence. The scan data is compelling, but it is not yet definitive, because scans are not excavations, and sensor returns are not physical artifacts in hand. The institutional caution has a rational basis, but rational caution and motivated avoidance can produce the same observable behavior, and from the outside, when you are looking at the texture of an institution's response, it can be very difficult to distinguish between them. Let me shift the frame for a moment, because the tunnel network beneath the St. Lawrence Valley cities, if that is what the scan data is showing, does not exist in isolation. It belongs to a category of discovery that has been accumulating across North America over the past 2 decades, with increasing frequency, driven by the same technological revolution in subsurface mapping that produced the Canadian scan data in the first place. LiDAR, ground-penetrating radar, satellite synthetic aperture radar, acoustic subsurface profiling. These technologies are finding things that have been present in the ground for centuries or millennia, and that were invisible because the tools capable of detecting them did not exist. And what they are finding, across an astonishing range of sites, is consistency, not specific artifacts, not the same architectural style or the same material culture, but a consistent pattern. Pre-contact. North America was more built than we thought, more modified, more organized at scales that require forms of social and technical coordination that the old Clovis first, small band of nomadic hunters model simply cannot account for. The LiDAR mapping of the Amazonian basin, conducted by a multinational research team beginning in 2017, revealed, beneath the canopy of the supposedly pristine rainforest, a network of cities, roads, earthworks, and agricultural modifications covering an area comparable to France, not a village here and a village there, not scattered settlements, a connected, modified, managed landscape of urban scale, home to millions of people, organized in ways that required sophisticated governance, long-distance coordination, and sustained agricultural production. The forest was not ancient and untouched. The forest was a garden, a post-collapse garden, grown back over the ruins of a civilization that ended for reasons still being debated, but a garden nonetheless, cultivated by a civilization that the standard pre-LiDAR archaeological consensus had described as sparse, migratory, and incapable of the infrastructure the LiDAR was now revealing. The parallel with the Canadian tunnel data is not exact. The Amazon discoveries are surface and near-surface features, visible in reflected light, while the Canadian tunnel network is deeply subterranean and visible only to acoustic and electromagnetic tools. The Amazon civilization is roughly contemporary with pre-Columbian cultures that the existing consensus already acknowledges as sophisticated, while the Canadian tunnel data may imply something much older. But the shape of the discovery process is the same. Technology finds something that should not be there by the standards of the existing model. The existing model resists. The evidence accumulates. The resistance modifies. The model changes. The question is always how long the cycle takes and how much is lost in the resistance phase, when data is filed away and conversations are had quietly in institutional corridors and nothing moves. In the Amazon case, the cycle from initial LiDAR revelation to mainstream academic acknowledgement took approximately 3 years. The Canadian tunnel data has been circulating in its preliminary form for, by the best estimates of those familiar with the review group timeline, something between 18 months and 3 years. Whether acknowledgement is approaching or receding is not clear from the available information, but the pattern suggests it is approaching, because this is how it always goes. The data does not wait, it accumulates. People who review it talk to other people. Some of those people talk to journalists. Some of them write blog posts and academic commentaries and letters to professional societies. The circle of people who know widens, and eventually the weight of what is known becomes more difficult to manage than the difficulty of acknowledging it. There is an elder of the Huron-Wendat nation, a woman in her late 70s who has spent her life as a keeper of certain traditions that her community transmits through direct oral instruction, who agreed to speak with one of the researchers working on the informal review of the scan data. The researcher asked her, as delicately as she could manage, whether the traditions she kept included any reference to underground passages or spaces in the territory that is now Quebec City. The elder's response, as the researcher later wrote it down, was not surprise. It was something closer to recognition. The elder said that she had been waiting for people to start asking this question. Not this specific researcher and not this specific conversation, but this question, the question of whether the world beneath the old city was known to her people. She said it had been known. She said it was still known, though not in the way it had once been known, because the knowing had become partial over the centuries of disruption since contact, and because the transmission had been broken in certain places, where people who carried specific portions of the knowledge had died without being able to fully pass it on. She said that what she could tell the researcher was that the passages were older than the Wendat. They had been there before the Wendat came to that territory. They had found them, they had used them, they did not build them. She said this clearly and without hesitation. The passages had been built by someone who was there before everyone she could name. Before everyone she could name. That phrase sat with the researcher for a long time, and it sits with everyone who hears it afterward, because it points toward a dimension of North American prehistory that the existing frameworks have been the most reluctant to engage with. The possibility that the human presence in this hemisphere is not just older than the Clovis model allowed, but older by an order of magnitude that changes the entire nature of the question. That what has been happening in North America for the past 13,000 years, or the past 30,000 years, or the past 130,000 years, is not the whole story, but only the most recent chapter of a story that began much earlier and that has left its traces, faint and buried and difficult to read but present, in the ground beneath our feet. To understand what before everyone she could name might mean in terms of actual human time in North America, you need to sit with the most uncomfortable findings in recent American archaeology, the ones that the mainstream press has covered briefly and then moved on from, but that specialists have not moved on from because the evidence does not permit it. The case of Kennewick Man is one of the most publicly known of these findings, though its full implications were largely buried under the legal and political drama that surrounded it. In 1996, the partial skeleton of an adult male was found eroding from the bank of the Columbia River near Kennewick, Washington. Initial assessment suggested the bones were those of a European-American settler, perhaps from the 19th century. Then the radiocarbon dates came back. The skeleton was 8,500 years old. And the morphology of the skull, when physical anthropologists began analyzing it, did not match the morphology of the indigenous populations that had lived in that region historically. It was closer, in the measurements, to certain Asian populations and to the Ainu of Japan than to the ancestry groups. The skeletal remains of confirmed Clovis-era individuals typically resembled. What this meant, and what the decade-long legal battle over the rights to study the remains obscured more than illuminated, was that 8,500 years ago, there was an adult man walking around in what is now Washington state, who was ancestrally distinct from the populations that are typically described as the first North Americans, not a different species, not even, necessarily, a different migration wave in any dramatic sense, but a different genetic line, one that spoke to a more complicated and more diverse pattern of early American population than any single migration narrative could accommodate. The legal case that followed, in which indigenous nations sought repatriation of the remains on the grounds that any pre-contact human found in their territory was ancestrally related to them, and in which scientists argued for continued study of remains that represented a poorly understood chapter in human prehistory, was never cleanly resolved. The bones were eventually returned for burial in 2017, with a limited study protocol that allowed a DNA sample to be taken. The DNA results showed a degree of genomic similarity to modern South American indigenous populations, which was consistent with neither the initial European resemblance assessment nor the specific Ainu comparison, and which added another layer of complexity to an already complicated picture. What the Kennewick case demonstrated, along with dozens of other early American skeletal finds that have produced morphological and genetic data inconsistent with a single Beringian migration origin, is that North America was populated through a process that was not simple, not linear, and not as well understood as either scientists or governments have typically communicated to the public. The people who were in North America before the populations whose descendants are alive today were diverse. They came from multiple origins, through multiple routes, at multiple times. Some of them left traces in the genetic record of living populations, and some of them apparently did not, leaving only skeletal and material culture evidence that is subject to all the losses and biases that the archaeological record always carries. The question of whether some of them were capable of the engineering implied by the Canadian tunnel data is not a question that can be answered by saying that all pre-contact North Americans were nomadic hunters. That answer was never entirely accurate and is now demonstrably inadequate. The coastal migration hypothesis, which has become increasingly supported over the past decade of genetic and archaeological research, proposes that some of the earliest human entrants to the Americas came not through an interior ice-free corridor, but along the North Pacific coast, in watercraft, island hopping from the Asian mainland along the now largely submerged Kelp Highway that provided food resources and navigational landmarks all the way from northeastern Asia to the Pacific coast of the Americas. The evidence for this route has been building since the early 2000s, and it has the virtue of explaining the presence of ancient human populations in South America that predate any plausible timeline for migration via the interior corridor. If people were moving along the Pacific coast as early as 16,000 years ago, perhaps earlier, they could have reached South America in the time frame that sites like Monteverde require, and they could have moved inland from the coast as they progressed southward and the coastal terrain allowed it. What this route implies for the St. Lawrence Valley is not immediately obvious, because the valley is on the Atlantic coast, not the Pacific. But it is connected, through the geography of the continent, to possibilities that the interior corridor route alone does not provide. Populations moving down the Pacific coast would have entered a continent where the interior was largely ice. They would have spread along the coast and then, as the ice retreated, moved inland through the newly exposed valleys and river systems. The St. Lawrence Valley, one of the largest and most navigable river systems in North America, would have been among the most accessible routes into the interior once the ice cleared. And the ice cleared from the St. Lawrence Valley very early in the deglaciation sequence, because the valley runs almost due east-west and the retreating glacier margin moved across it from east to west, exposing the downstream sections while the upstream sections were still glaciated. By 12,000 years ago, significant portions of the lower St. Lawrence were ice-free. By 11,000 years ago, the valley was largely open and the Champlain Sea was beginning to drain. By 10,000 years ago, the modern river system was establishing itself in recognizable form. That is a very long time. 10,000 years of potential human habitation in a landscape that is now covered by two of Canada's oldest colonial cities. 10,000 years of possible modification, construction, use, abandonment, reuse, and burial by subsequent accumulation. The palimpsest of what 10,000 years of human activity in a landscape looks like is something that the new scanning technologies are only just beginning to be able to read. And what they are reading in this particular landscape is something that challenges every comfortable assumption about what was here before the French built their fort on the rock and named it Quebec. There is a specific pattern in the LiDAR and ground-penetrating radar data from the Northern Survey Zone that one of the researchers in the informal review group has described as the most troubling detail in the entire dataset, more troubling even than the artifact scale return in the northern terminus chamber. The pattern is in the relationship between the subsurface tunnel features and the surface topography of the bedrock beneath the modern soil cover. The bedrock surface in the survey zone is not smooth. It has been shaped by glaciation, modified by subsequent erosion, and in some areas, artificially leveled by modern construction. But in one stretch approximately 400 meters long and running roughly parallel to the primary tunnel axis, the bedrock surface shows a series of regular depressions, spaced at intervals of approximately 12 meters, each depression roughly circular in plan, and each one positioned almost exactly above a point on the tunnel feature, where the acoustic mapping shows a variation in the ceiling height. The depressions are not on the surface today. They are at the bedrock surface, beneath 2 to 4 meters of post-glacial sediment and modern fill, invisible without the scanning data. They line up with the tunnel below, and the spacing, 12 meters, repeated consistently along 400 meters of the feature, is not a spacing that appears in any natural geological process the review team has been able to identify. 12-meter spacing repeated consistently along a linear feature is a constructed spacing, not conclusively, not beyond all possible natural explanation. But the probability calculation that the acoustic mapping specialist did, comparing the observed spacing regularity against the expected variance from random geological processes in this rock type, produced a p-value that she described as embarrassingly low, meaning that if the feature were geological, what they are seeing would be extraordinarily improbable, not impossible. But the kind of improbable that, in any other context, researchers would feel comfortable dismissing as a natural explanation and investigating the alternatives. The alternatives, in this case, are limited but significant. The regular depressions could be access shafts, vertical connections between the surface and the tunnel below, cut from above, used for ventilation or for moving materials up and down during construction or use. The spacing would be consistent with a design where ventilation was provided at regular intervals to allow workers or users to breathe comfortably in a long tunnel without mechanical air circulation. This kind of shaft-ventilated tunnel construction is known from the Kharez systems of the Middle East and Central Asia, where underground aqueducts were built with vertical shafts at regular intervals, both to allow construction access and to provide ongoing ventilation and maintenance access. The spacing in those systems varies by location and builder, but 12 meters is within the range of typical Kharez shaft spacing for a tunnel of the diameter suggested by the Canadian scan data. The parallel is not proof. The parallel is a possibility that the data does not exclude and that the evidence pattern actually supports. If the depressions are access shafts, they are sealed. The acoustic data shows no opening connecting the shaft depression to the tunnel below. Either the shafts were deliberately blocked at some point after the tunnel ceased active use, or they were blocked by natural sediment infilling over time, or the seal was always there, and the shafts represent something other than active access points. Perhaps simply construction survey points used to verify alignment during the tunneling process and then filled in once their purpose was served. Any of these explanations is technically feasible. None of them reduces the significance of the underlying finding. If the depressions are access shafts of any kind, the tunnel was built with intention and foresight sufficient to plan a multi-point, surface-to-subsurface construction methodology. That is engineering. Whatever the word choice that is ultimately settled on for the feature, whatever it ends up being called in a peer-reviewed publication when one is finally produced, it is engineering. The parallel that the research team has been most reluctant to draw, but that has been drawn in the informal conversations that have been shared more widely, is to the network of underground structures found beneath the ancient city of Teotihuacan in Mexico, beneath the Pyramid of the Sun, beneath the Temple of the Feathered Serpent, beneath the Avenue of the Dead. Archaeologists have discovered over the past decade a complex of tunnels, chambers, and ceremonial spaces that were built deliberately, sealed deliberately, and filled with a remarkable collection of offerings, figurines, pyrite mirrors, greenstone beads, obsidian blades, pottery, and the remains of animals and, in some locations, human beings. The Teotihuacan underground complex is not a marginal or disputed finding. It is extensively documented. It was built by one of the largest cities in the ancient world, a metropolis of perhaps 150,000 people at its peak around the year 500 of the Common Era, who, for reasons that remain partially obscure, decided to construct a subterranean counterpart to their surface city, a mirror world beneath the visible world. Teotihuacan is in Mexico. The St. Lawrence Valley is in Canada. The cultural distance between them is vast. The temporal distance may or may not be vast, depending on how the Canadian tunnel data is ultimately dated, which requires either material from the physical feature or indirect dating from associated context, neither of which is yet available. But the spatial correspondence between tunnel networks and major urban or ceremonial sites is not unique to either location. It is a pattern. Across pre-Columbian North America and Mesoamerica, underground construction is associated with the most significant places, the places where the largest communities gathered, the places where the most important events were commemorated, the places that subsequent generations remembered and returned to. If the Canadian tunnel network is what the scan data suggests it is, its location beneath what became Quebec City and Montreal is not coincidental. Those places were significant before the French and British arrived. The significance is what drew people there, across cultures and across centuries. The tunnel network may be why. Let me spend some time with the specific geography of Quebec City, because the geography is important in ways that go beyond the geology. The city sits on a promontory, a great craggy rock called Cap Diamant, that rises almost 90 meters above the St. Lawrence River. From its height, you can see downstream for many kilometers. You can see upstream for many kilometers. You can see the point where the Chaudière River enters from the south, and you can see the broad basin where the river widens before the Ile d'Orléans divides the channel. This is a commanding position. It is a position from which any traveler on the river is visible long before they arrive. It is a position from which communication in multiple directions is possible. It is, in purely military and strategic terms, one of the most defensible and observationally powerful positions in the entire river system, which is precisely why the French chose it for their settlement, and why the British fought so viciously to take it from them, and why it became and remains a fortified city in a way that few North American cities are. But Cap Diamant was significant long before the French. The Algonquin and Haudenosaunee peoples both recognized its importance. The word from which Quebec derives its name is itself an Algonquin word, Quebec, meaning where the river narrows, or in some translations, where the waters meet. The naming reflects a geographic reality that any traveler on the St. Lawrence would immediately recognize. The promontory is a landmark. It is the kind of place that is remembered across generations, that becomes a reference point in geographic memory, that accumulates significance because it is the kind of place that repeatedly draws people who know the landscape. The primary tunnel feature in the Quebec City scan runs beneath this promontory, not beneath the flat lower town, beneath the rock, through the rock. The northern end of the primary passage appears to run toward the base of the promontory from the inland side. The southern branches reach toward the river. Whatever the tunnel network was designed to do, it was designed in full awareness of the promontory's position in the landscape. It was designed in relationship to the landmark that has defined this geography for every human culture that has known it. That relationship is not something that can be dismissed as coincidence or convenience. It is a design choice. Whoever built the tunnel network understood this landscape the way you understand a place you have known for a very long time. From the inside, from the ground level, from above, and now from below. They understood what the promontory was, and they built into it. That tells you something about the depth of their relationship with this specific terrain, and it tells you something about the scale of their ambition. Because tunneling through the limestone of Cap Diamant, at the depths the scan data suggests, is not an incidental engineering task. It is a primary engineering task. It is the hardest part of the entire network. It required the most planning, the most sustained effort, the most precise knowledge of where to go and how to get there. Whoever built the tunnel went through the most difficult part of the landscape first, which means they had a reason that was worth doing the most difficult part first, which means they knew where they were going and they knew what was on the other side. And what is on the other side of Cap Diamant, from the river, is the St. Lawrence itself, the great river, the highway of the continent, the corridor that connects the interior to the sea. The water road along which everything, people and goods, and information and influence, has moved through this part of North America for as long as anyone has been here. The tunnel goes toward the river. It goes through the rock. It comes out somewhere in or near the water, or at a point near the water's edge, or at a position that provides access to the river from a location that is not visible from the river surface, not visible from the promontory above, not visible from any approach that a traveler on the water would take. It is a hidden river connection. Whatever was going through the tunnel, whoever was going through it, they were doing so invisibly. They were moving between the interior of the promontory and the river without being seen. For 3.5 meters of bore diameter, and whatever depth of clearance the riverside terminus provides, they could move things. Quietly, secretly, safely. Below the sightlines of anyone watching the surface of the landscape, what you do with a hidden river connection in the context of a commanding promontory that has strategic importance in every human framework that has ever recognized this geography is something that depends entirely on who you are and what you are trying to accomplish. The possibilities are not small. The Montreal findings, which I described in outline earlier, deserve their own extended attention because they are different in character from the Quebec City data in ways that suggest either a different builder, a different time period, a different purpose, or some combination of all three. The quasi-grid organization of the Montreal subsurface features is the detail that most consistently confounds the researchers who have reviewed the data, because grids are not accidental. A grid requires planning in 2 dimensions simultaneously, requires the ability to maintain parallel and perpendicular alignments across distances of hundreds of meters in solid rock, and requires a governing intention to organize space in a regular, repeatable pattern rather than a responsive, terrain-following one. The Quebec City tunnel follows the terrain. It curves. It adjusts. It is a path through the landscape. The Montreal feature imposes a geometry on the landscape. It is a plan. These are fundamentally different design philosophies, and they suggest fundamentally different builders or fundamentally different purposes. The word grid is being used loosely here, because what the scans show is not a clean orthogonal grid of the kind that a Roman military surveyor would have laid out. It is more like a damaged grid, a partial grid, a grid from which sections are missing, or a grid that was planned but not completed, or a grid that was completed but from which sections have been lost to natural void collapse or deliberate infilling. The researchers who have analyzed the Montreal data most carefully describe it as a system of parallel passages at 2 orientations, roughly northeast-southwest and northwest-southeast, intersecting at near right angles, with chambers at some but not all intersections. The chambers are not uniform in size. Some are small, barely wider than the passages. Some are significantly larger, with the scan data suggesting internal dimensions of 6 meters or more across. The distribution of large versus small chambers follows no pattern that the research team has been able to characterize as regular or predictable. What this irregular distribution of chamber sizes suggests, to the researchers most familiar with comparative underground architecture, is a functional differentiation. Different chambers serve different purposes. The small ones may have been intersections, decision points, junctions where a traveler moved from one passage to another. The large ones may have been meeting points, storage areas, working spaces, or ritual spaces. The combination of a movement infrastructure with a set of differentiated functional spaces is the combination you get in buildings, in structures that served complex purposes. In architecture, in the full sense of the word, not just construction, the Montreal subsurface complex, if that is what the scan data is showing, is not just a tunnel. It is a network of spaces that served multiple different functions, organized in a plan that was both geometrically regular and functionally varied. It is, in architectural terms, a building, a very large, very deep, very ancient building. The question of what was in the large chambers is unanswerable from the scan data alone, but the acoustic mapping provides some indirect evidence that has been interpreted with caution but with consistent conclusions by the 4 specialists who have reviewed it independently. The floor signatures in the large chambers are not uniform. In 2 of the large chambers, the floor return is consistent with the native limestone, indicating a natural or minimally modified stone surface. In 3 others, the floor return is different, denser in a way that suggests surface treatment similar to what I described in the Quebec City terminus chamber. And in 1 chamber, the acoustic return from the floor region includes multiple discrete object signatures. Not one artifact scale return, but several, distributed across the chamber floor in a pattern that one of the acoustic specialists described as a scatter, suggesting objects that were either deposited over time or disturbed from an original arrangement by some process that occurred after deposition. Collapse, seismic activity, water infiltration, deliberate disturbance. The acoustic data cannot distinguish between these possibilities, but the objects are there, multiple objects. On the floor of a sealed underground chamber in the bedrock beneath the city of Montreal, these objects, like the single object scale return in the Quebec City terminus chamber, have not been physically investigated. They are known only through their sensor signatures. Their material composition, their size, their form are all still unknown. The only thing that can be said about them with confidence is that they are there and that they were not formed there, because the acoustic return profiles are not consistent with geological formation in the bedrock of this type and age. They are things that someone put in a room that was then sealed and buried and built over by centuries of subsequent human occupation and colonial construction and the relentless modern expansion of one of Canada's largest cities. They have been waiting there, in the dark and the silence and the cold of 40 meters of rock, for longer than anyone currently knows. There is something deeply affecting about this, when you sit with it long enough. Not the mystery, though the mystery is affecting. Not even the implication of antiquity, though the antiquity is staggering. What is affecting is the thought of the people who made these spaces, who put these things in these places, who sealed the chambers and left. Who knew, at the moment of sealing, that what they were leaving behind was going into a darkness that might last longer than they could comprehend. Perhaps they expected to return. Perhaps they did return, or their descendants returned, before the knowledge was finally lost in the disruptions that the oral traditions describe, in the violence and displacement and cultural rupture of the pre-contact period and then the colonial period. Perhaps the sealing was final and deliberate, a permanent closure made in the knowledge that whatever was inside was being given to the future in the only way that was available, buried, protected, waiting. The Haudenosaunee oral tradition includes a concept that scholars translate variously as the buried knowing or the sleeping memory. The idea is that certain kinds of knowledge are intentionally put into a state of suspension, not forgotten but not actively circulated, preserved in a form that can survive periods when the active transmission is impossible, encoded in places, in landmarks, in the physical arrangement of the landscape itself, rather than in living minds that can die or be broken. The buried knowing waits until conditions are right for it to be awakened, not by being dug up, necessarily, but by being recognized, seen again, connected to the living tradition that has been, perhaps fragmentarily and imperfectly, waiting for it on the other side of the darkness. The elder who spoke with the researcher, who said that the passages had been built by someone who was there before everyone she could name, also said one other thing that has stayed with everyone who has heard it. She said that her people had a name for what would happen when the passages were found again, not excavated, not studied, but found, recognized, acknowledged. She said the name translated, very roughly, as the ground speaking. She said it was considered, in the tradition she kept, to be one of the signs that the world was turning back towards something it had moved away from. She did not specify what that something was. She did not say whether she believed the scan data represented the ground, speaking in the sense the tradition described. But she said she had been waiting, for a long time, for someone to ask the right question. And she said that the question the researcher had asked, whether the underground passages were known to her people, was the right question, or very close to it. The closer question, she said, was not whether the passages were known. It was whether the people who built them were known, whether anyone still remembered them, whether their name had survived. That question, whether any name has survived for the people who built the tunnel network, is one that leads into the most speculative and most fascinating territory of this entire inquiry, because names, in the oral traditions of North America, are not just labels. They are histories. They are compressed knowledge systems. They carry in their phonology and their etymology and their ceremonial context information about origins and relationships and capabilities that written language often strips out in the translation. When a name for a people or a place or a practice survives in an oral tradition, it sometimes survives with enough information attached to it to be connected, with careful scholarly work, to archaeological and historical contexts that written records alone would never reveal. And there are, in the oral traditions of several nations in the St. Lawrence region, names for predecessors, for the people who were there first. Names that are not names for any nation currently recognized in the historical or anthropological record, but names for a presence that the oral traditions consistently describe as ancient, as builders, and as departed. The Wendat oral tradition includes references to a people called, in one translation, the stone carvers. In another, more literal translation of the same term, the people who go inside the rock. The term appears in several independent accounts that anthropologists collected at different times from different communities, which suggests it is not an artifact of a single narrator's embellishment, but is part of a shared traditional vocabulary. The stone carvers, in the accounts that survive, are described as the people who made the beneath places, who created the paths through the rock, who knew the rock from the inside in a way that no one after them had fully recovered. They are not described as gods or supernatural beings. They are described as people, ancient people. People whose time in this landscape preceded the Wendat's own arrival by an interval that the traditions characterize as very long, but do not quantify in any way that can be converted to modern chronological terms. Long enough that their works were old when the Wendat found them. Old enough that the Wendat did not know how old. The Algonquin oral tradition has its own version of this reference, using different terminology but describing a recognizably similar concept. The people who shaped the underground, who worked in stone, who left behind spaces that were already ancient when the ancestors found them. The Algonquin term used in the oldest available records translates roughly as the elder builders, with a connotation of both temporal seniority and architectural capacity. They are referenced in the context of specific places, including at least one location that corresponds geographically to the northern survey zone of the new scan data, the site where the multi-level passages were found, where the parallel tunnels separated by a constructed floor appear in the acoustic data. Two separate oral traditions, from two separate nations, with two separate linguistic families, referring to a category of ancient predecessors who built underground in the landscape that the scan data is now revealing to contain exactly that kind of ancient underground construction. The coincidence accumulates, or rather, the evidence accumulates. Coincidence requires that these two facts be unrelated. The possibility that they are related, that the oral traditions have been accurately preserving memory of the builders of the tunnel network for centuries or millennia, is not smaller than the possibility of coincidence. It is, given the specificity of the geographic correlations and the consistency of the thematic content across culturally distinct traditions, considerably larger. The researchers who take both the scan data and the oral traditions seriously are not, by and large, people who approach either body of evidence naively. They are people who understand the limitations of each and who have arrived at a position of taking both seriously, precisely because the limitations of one are compensated by the strengths of the other, and vice versa. The scan data is physically precise, but interpretively ambiguous. You know exactly where the features are, and you know quite a lot about their geometry, but you cannot know, from the scan data alone, who made them, or when, or why. The oral traditions are interpretively rich, but geographically imprecise. You know something about who the predecessors were and what they did, but you cannot know, from the oral traditions alone, exactly where the features are located or what they look like in physical terms. Together, they produce something that neither produces alone, a picture, not a complete picture, not a photograph, but something more like a rough map, drawn partly in stone geometry and partly in inherited words, of a chapter of North American history that has been waiting, in the dark and the silence, for the moment when the right tools and the right questions finally arrived at the same time. The question of when the tunnel network was built is the question that determines whether what the scan data is showing is remarkable or genuinely paradigm-shifting. If the network was built in the last few thousand years, the second or first millennium before the Common Era or the early Common Era, it is remarkable but accommodatable within an expanded understanding of pre-contact North American civilizational capacity. It would require acknowledging that significantly more complex social organization and engineering capability existed in the Lawrence Valley than the current consensus accepts. but it would not require a fundamental restructuring of human prehistory in the Americas. It would be, in the historical framework, a gap filled, a previously unknown chapter of a story whose other chapters are reasonably well understood. If the network was built before the Champlain Sea drained, before 9,000 years ago, that is a different magnitude of revision. If it predates the glacial retreat, if there are elements of it that somehow survive the ice itself, that is a revision of a magnitude that essentially no one in mainstream academia is currently prepared to entertain, and that would require evidence so extraordinary that even the most enthusiastic advocates of pre-Clovis antiquity for North American cultures would apply stringent scrutiny. The dating evidence available from the scan data alone is not sufficient to answer this question. Acoustic and electromagnetic subsurface mapping does not produce dates, it produces geometry. To date the features, you would need physical samples, either from the material of the tunnel walls themselves if they have been artificially treated, from any organic material trapped in the void spaces during whatever sedimentation may have occurred there, or from the objects the scan data shows resting on the chamber floors. All of those require physical excavation. Physical excavation has not been authorized. So the dating question sits unanswered, and the range of possibility remains enormous. What can be said, on the basis of indirect evidence, is that the features are old enough to have been covered by the sediment accumulation that the scan data shows above them, and old enough that no historical record from the colonial or even the late pre-contact period makes reference to them, which means they were either fully sealed and inaccessible by the time European documentation of the landscape began, or they were known and the knowledge was not shared with European observers, or they were known and the knowledge was actively suppressed. All three of these possibilities have parallels in the history of this particular region. The colonial suppression of indigenous geographic knowledge in the St. Lawrence Valley is a documented historical phenomenon, not a conspiracy theory. The French colonial administration, from the earliest period of contact, was specifically interested in gathering geographic and navigational information about the river system and its tributaries, and it depended heavily on indigenous guides and knowledge keepers for that information. The records of the early Jesuit missions, who were often traveling with indigenous guides into territories that no European had previously seen, include dozens of instances where indigenous guides declined to share specific geographic information, sometimes simply stopping at certain points and refusing to proceed, sometimes offering explanations that the Jesuits recorded with evident frustration as superstitious, sometimes giving directions that the Jesuits later realized were deliberately misleading. The Jesuits interpreted this behavior as irrationality or deception. The more sympathetic reading, available with the benefit of historical distance, is that the indigenous guides were protecting specific places and specific knowledge from people they correctly understood to be colonizers with extractive intentions. Whether underground tunnel networks were among the things being protected is not something the Jesuit records can confirm, but the pattern of deliberate geographic non-disclosure to European observers is well established. The active suppression of knowledge runs in the other direction as well. The colonial and post-colonial Canadian state has a documented history of suppressing, discouraging, and actively dismantling the transmission mechanisms of Indigenous knowledge, most egregiously through the residential school system that operated in Canada from the 1870s through 1996, which removed Indigenous children from their families and communities, forbade the use of Indigenous languages, and explicitly aimed to eliminate the cultural transmission systems through which oral traditions, including geographic and historical knowledge of the landscape, were maintained across generations. The knowledge losses from this system were catastrophic and are still being inventoried by the communities that survived it. Whether knowledge of the tunnel network was among the things lost in the residential school period, whether the partial and fragmentary quality of the oral tradition references to the beneath places and the stone carvers reflects losses from this period specifically, is something that elders and knowledge keepers in the communities involved are better positioned to assess than any outside researcher. But the fact that the knowledge exists in fragmentary rather than complete form, the fact that the elder who spoke with the researcher described the transmission as having been broken in certain places, is consistent with the kind of damage the residential school system is known to have caused. The colonial-era suppression of archaeological and geographic information cuts in a different direction as well. There is a persistent pattern in the history of Canadian and American archaeology of significant finds being made during colonial and industrial development of the landscape, being noted briefly and then being absorbed into the construction project that occasioned them without any systematic documentation or investigation. The excavation of basements for commercial buildings in Montreal in the late 19th and early 20th centuries, which cut through the glacial and post-glacial sediments below the old city core down to bedrock, must have cut through whatever stratigraphic record exists above the tunnel network features. If the shallow portions of the Montreal subsurface complex had any connection to the sediment layers above them, those connections would have been encountered and destroyed by the basement excavations of the commercial building boom. The workers who encountered anomalous features, whether passages or chambers or unusual stone formations, were not archaeologists. They were construction workers operating on a production schedule with a foreman who needed to see the concrete poured. Anomalous features got reported to foremen or didn't get reported at all, and in either case, they mostly got concreted over without documentation. This is not a story of deliberate cover-up. It is a story of institutional indifference and the structural invisibility of things that don't fit the framework of the people doing the looking. There are, buried in the municipal archives of Montreal and Quebec City, records of anomalous encounters during construction that have never been systematically analysed in the context of underground features. 19th century newspaper accounts of construction workers encountering what was described as underground passages during foundation excavations for buildings in the old city of Quebec, accounts that were published as curiosities, attributed to French colonial-era construction or to natural geological features, and then forgotten. Municipal engineering reports from the early 20th century that note the discovery of unusual void spaces beneath certain streets that were filled with concrete as part of normal infrastructure maintenance and never investigated. Further, a mid-century account, published in a regional historical journal and never widely cited, of a sewer construction crew in Montreal who broke through into a space that one of the workers described as a room with walls that were smooth, smoother than the surrounding stone, and a floor that was flat in a way that rock doesn't usually get. The account is attributed to a specific worker whose name is given. The sewer was completed on schedule. The space was incorporated into the sewer infrastructure. No one followed up. That worker's description, smooth walls and a flat floor, matches what the acoustic mapping data shows for the interior characteristics of the chambers in the Montreal subsurface network. Smooth, treated walls, level, modified floors. The details are consistent. The worker who noticed them in the 1940s had no way of knowing that his observation would eventually be consistent with scan data produced 60 years later, because the scan data did not exist, and the possibility it was revealing would not have occurred to him even if it had. He noticed something strange. He noted it. He went on with his work. The city grew over it. And now, 60 years later, the machines look down through the city's layers and find, in the geometry of the rock, the confirmation that what he saw was real. These historical fragments, these scattered accounts from workers and engineers and municipal administrators who encountered something they did not have a framework to understand, are not individually compelling. Each one is easily dismissed, but together they form a pattern that is consistent with the presence of exactly the kind of subsurface feature the new scans are showing. The pattern of glimpses, brief, incomplete, unremarkable in isolation, consistent only when you step back and look at all of them at once. The glimpse in the oral tradition, the glimpse in the Jesuit records of geographic non-disclosure, the glimpse in the construction worker's description of smooth walls and a flat floor, the glimpse in Theodore Marchant's memory of anomalous subsurface features logged and filed and never revisited, the glimpse in the acoustic specialist's reading of the scan data that her colleagues had not fully emphasized, the glimpse in the object scale return at the center of the northern terminus chamber. Together, they are not a coincidence. Together, they are a shape. The shape of something that has been present in this landscape, known in fragments and in silence, and in buried records, and in acoustic waves bouncing back through 42 meters of rock, for longer than anyone currently knows. The question that this accumulation of fragments points toward, the question that the scan data and the oral traditions and the historical glimpses and Theodore Marchant and Isabelle Fontaine, and the acoustic specialist and the researcher who described the institutional response as management rather than investigation, are all pointing toward, is not a small question. It is not a question about a tunnel network beneath two Canadian cities. It is a question about what happened in North America before the things that we know happened, about who was here and what they built and what they knew, and why the knowing went into the dark so thoroughly that it took the most sophisticated scanning technology of the 21st century to begin to bring it back. And that question, I want to be precise about this, is not one that I am going to resolve for you tonight, because it has not been resolved. The evidence is real. The scan data is real. The correlation with the oral traditions is real. Theodore Marchant's professional judgment is real. Isabelle Fontaine's cast analysis is real. The object scale returns in the sealed chambers are real. The regular spacing of the surface depressions above the tunnel axis is real. All of it is real. And none of it is yet enough to close the question of what it means. That closing, that resolution, requires the one thing that has not yet been authorized. The excavation, the physical opening of the ground, and the careful, professional, respectful, thorough investigation of what is inside. That has not happened yet. And until it happens, what the scans are showing remains exactly what the word anomaly implies. Something that exists outside the expected pattern. Something that is real, but not yet explained. Something that is waiting. The waiting, in this case, has a particular quality that other mysteries of this kind do not always have. Because the community of people who have reason to care about what is in that ground, the indigenous nations whose ancestors may have known it or built it or both, the archaeologists whose professional understanding of the continent's past would be transformed by its investigation, the geologists whose models of geological process in this terrain would need to be revisited, the historians whose narratives of Canadian and North American prehistory would require revision, and the ordinary people, curious and awake in the small hours of the morning, who sense that the official story is missing something, are all waiting together, not always comfortably, not always in agreement about what should happen next, but together in the way that all true mysteries bring people together around the thing that cannot be fully known and cannot be entirely ignored. Whatever is in the sealed chamber at the northern terminus, whatever is distributed across the floor of the Montreal chamber with the multiple object scale acoustic returns, whatever the surface treatment on the interior walls of the primary tunnel was made of and applied for what purpose, whatever the regular spacing of the surface depressions above the tunnel axis was designed to achieve, whatever the oral tradition of the Wendat elder means when it names the builders the people who go inside the rock, whatever the geologist meant when he said the network looked purposeful, all of that is still there, still in the ground, still waiting for the right question, or the right tools, or the right moment, or the right combination of institutional will and indigenous consent, and professional integrity and ordinary human curiosity to bring it to the surface. Let me return to the Northern Survey Zone, because the features found there are the ones that most directly challenge any comfortable accommodation of the scan data within the existing historical frameworks. The decision to extend the survey corridor northward from the urban sites was made, as I described earlier, almost as a formality, an expectation check that turned into a discovery that the team did not anticipate, and has not, in the months since, fully managed to process. The features in the Northern Survey Zone are deeper, they are more irregular in their surface treatment signatures, and they include the detail that has generated the most internal debate. The multi-level passage structure where two tunnels run parallel at different depths, separated by what the acoustic data characterizes as a constructed floor. The Northern Survey Zone is in Canadian Shield terrain. This is important geologically because the Shield is Precambrian basement rock, the oldest and hardest rock exposed at the surface in North America. It is not limestone. It is granite and gneiss and quartzite, rock that is orders of magnitude harder to work than the Ordovician limestone of the Quebec City and Montreal sites. The tools required to excavate through Canadian Shield basement rock are different in kind from the tools that would suffice for limestone. Stone tools that can work limestone cannot, except with extreme effort and enormous expenditure of time, work granite. The conventional wisdom about pre-contact North American underground construction, to the extent that any such construction has been entertained as a possibility, has operated on the assumption that where it might have occurred, it would have occurred in softer rock types, in limestone or sandstone, where stone tools are mechanically adequate. The Northern Survey Zone data challenges this assumption directly because the multi-level passage structure is in granite, and granite does not respond to the same excavation techniques that limestone does. The most effective technique available to pre-industrial cultures for working hard crystalline rock, granite in particular, is thermal fracturing. The application of intense heat, followed by rapid cooling with water, exploits the differential thermal expansion of the mineral components of the rock to create fracture planes that can then be worked with wedges and hammerstones. This technique, sometimes called fire setting, was used extensively by ancient miners in many parts of the world. The gold miners of ancient Egypt used it in the hard quartzite of the Nubian desert. The copper miners of the Great Lakes region, whose mining operations date back at least 6,000 years, and who extracted enormous quantities of copper from the bedrock of the Lake Superior region without metal tools, used fire setting in combination with cold water quenching to fracture the rock around copper ore bodies. The Great Lakes copper mining tradition is itself one of the best documented cases of pre-contact North American industrial-scale rock working, and it demonstrates conclusively that the peoples of this continent, long before European contact, were capable of sustained, large-scale, technically sophisticated engagement with hard bedrock. They were not incapable of working rock. They were capable. The question has always been one of motivation and organization, not of technical sealing. The Northern Survey Zone multi-level passage, if it is what the acoustic data suggests it is, required fire setting or an equivalent technique in granite. It required sustained labor over an extended period, probably longer than the limestone tunneling of the urban sites because the material is harder, and it required the engineering foresight to excavate two levels simultaneously or in planned sequence, maintaining the relationship between them and the integrity of the floor between them. The floor between the two passages is described in the acoustic data as between 0.5 meter and 1 meter thick. That is a floor designed to bear load. A floor that was intended to have weight on it, either from above or from below or both. The implication is that both levels were used simultaneously, that whatever was happening in the upper passage and whatever was happening in the lower passage were different things, and that the builders knew they needed a floor between them capable of supporting both. This level of three-dimensional planning, the ability to conceive of and execute a multi-level underground structure in hard rock, is a capability that the existing archaeological consensus does not associate with any known pre-contact North American culture at any period. It is a capability associated, in the global archaeological record, with societies that had developed significant engineering specialization, that had accumulated substantial technological knowledge of rock behavior over extended time, and that had organizational systems sophisticated enough to coordinate multi-year, multi-phase construction projects involving dozens or hundreds of workers. The Minoan civilization built multi-story buildings. The Romans built multi-story underground structures. The Nabateans of Petra built elaborate rock-cut architecture in sandstone that incorporated multiple levels connected by internal stairways. All of these cultures are associated with periods and regions where the written record or the material culture record is extensive enough to document the organizational structures that made such construction possible. For the Northern Survey Zone, no such record exists. There is only the rock and what the scanning machines found inside it. One of the researchers reviewing the Northern Survey Zone data brought up, in the informal discussions that have circulated among the review group, the analogy of the Longyu Caves in China. The Longyu Caves are a complex of 24 large artificial underground chambers carved into siltstone in the Zhejiang province of eastern China, discovered in 1992 when a local farmer drained a pond and found rooms beneath it. The chambers are enormous, the largest more than 30 meters in height, and they are decorated throughout with parallel chiseling marks at uniform spacing on every surface, ceiling, walls, and floors. The marks are so regular that they look machine-made. They have been attributed to human craftspeople working with stone tools, and the craftsmanship is extraordinary even by the standards of cultures with long histories of stone working. The Longyu Caves have been radiocarbon dated to approximately 2,000 years ago, and despite the scale of the construction, The fact that 24 such chambers were excavated in this region, no historical record in Chinese sources, which are extraordinarily detailed for this period, makes any reference to the construction or to the culture that built them. They are, in the archaeological terminology, orphan structures. Structures without a parent culture in the written record. Structures that were built, used, sealed, flooded, and forgotten within the span of the documented historical record, without leaving any trace in that record. The parallel with the Canadian scan data is not perfect. The Longyou caves are known and physically accessible and extensively studied. The Canadian features are known only through scan data and physically inaccessible. But the pattern of sophisticated, large-scale, underground construction that exists outside the written or material culture record is a pattern that the Longyou caves establish as possible in principle. Underground construction at an impressive scale can occur in a well-documented historical period without leaving any trace in contemporary records. The absence of evidence for the construction of the Canadian features in historical records is therefore not, by itself, evidence of absence. It is a pattern that has parallels in documented cases of intentional or accidental secrecy around large underground projects. The climate of the Northern Survey Zone region during the period of maximum potential antiquity for the features, roughly 10,000 to 8,000 years ago, in the immediate post-glacial period, was dramatically different from the climate of that region today. The newly deglaciated landscape was undergoing rapid environmental change. The retreat of the ice exposed bare rock and outwash deposits. Vegetation colonized from the south. Animal populations, including the large herbivores that supported the megafauna hunting cultures of the late Pleistocene, were in flux. The communities living in this newly opened landscape were living through a period of extraordinary environmental change at a pace that had no precedent in any prior human cultural experience. The ability to create stable, protected underground spaces in this context, spaces that maintained consistent temperature, that were protected from the violence of weather in a landscape where the normal ecological buffers had not yet re-established themselves, that could serve as refuge from predators in a terrain where the apex predators of the late Pleistocene were still present in some numbers, as the glacial regime broke down, would have had enormous practical value. In this context, the investment in tunnel construction that the Northern Survey Zone data implies is not an incomprehensible luxury. It is a response to real survival pressures in a specific landscape at a specific time. The communities capable of undertaking it were doing so because they had compelling reasons, because the cognitive and organizational resources to plan and execute it existed in their culture, and because the time horizon of the project, even if it required multiple generations, was something their society was structured to accommodate. We know, from the evidence of the Great Lakes copper mining tradition, that pre-contact North American peoples were capable of sustained, intergenerational, industrially scaled projects of rock modification and material extraction. We know, from the Cahokia earthworks, that they were capable of sustained, intergenerational construction projects of enormous scale. We know, from the LiDAR revelations of the Amazon, that they were capable of modifying landscapes at civilizational scales without leaving traces readable to conventional surface archaeology. The question of whether they were also capable of tunneling is not a question about human capacity in the abstract. It is a question about organization, motivation, and time, and the post-glacial period in the newly opened Street, Lawrence, and Shield terrain provided all three. The fate of the builders is the question that haunts this entire inquiry in ways that are difficult to articulate but impossible to ignore. Whatever community or culture created the tunnel network, they are gone. Not necessarily without descendants, because genetic continuity is not the same as cultural continuity, and the descendants of the people who built the tunnels may well be among the living indigenous nations of the Street, Lawrence region, whose oral traditions encode fragmentary memory of the builders. But the tradition of building, the specific knowledge of how to tunnel through limestone and granite, and how to build multi-level underground structures, and how to treat the walls with whatever material the acoustic data is showing on the interior surfaces, that tradition did not survive in any form recognizable to the peoples who came after. It is gone. The oral traditions remember that it existed. They remember the people who possessed it, but they do not retain the technical content of the knowledge. the specific methods, the specific materials, the specific planning and organizational systems that made the construction possible. This loss is consistent with what we know about the catastrophic disruptions that have repeatedly reshaped the human landscape of North America over the past 10,000 years. The Younger Dryas event, a rapid cooling that occurred approximately 12,800 years ago and lasted for about 1,000 years, disrupted ecosystems across the Northern Hemisphere and is associated with population collapses in the archaeological record of several regions. The 8.2 kilo-year event, a rapid climate cooling about 8,200 years ago, produced significant drought conditions across the Northern Hemisphere and is associated with further population disruption. The Bronze Age collapse, which affected Mesoamerica, as well as the Old World in its various manifestations, produced disruptions whose cascading effects reached even into North America through trade network collapses and refugee movements. And of course, the European contact period, with its catastrophic epidemic disease, mortality, its warfare, its forced displacement, and its deliberate cultural destruction, produced losses in the historical period, whose full scope is still being assessed. Through all of these disruptions, knowledge can be lost, not gradually, not slowly, but catastrophically. A disease outbreak that kills 3/4 of a community in a single season can destroy the knowledge of the 3 or 4 specialists who held specific technical traditions that required decades of training and that were transmitted only orally. A violent displacement that moves a community hundreds of kilometers from their territory in a matter of months can sever the connection between the knowledge and the landscape it describes so completely that even the community that survives cannot recover it without returning to the place. The builders of the tunnel network may have been disrupted in exactly this way at some point in the past, in a manner that preserved the cultural memory that the work had been done, but destroyed the technical capacity to continue or extend it. What the oral traditions remember is not the how, it is the that. The stone carvers existed, they made the beneath places, they are gone now, the places remain. What the scans have done, what the astonishing sensitivity of 21st century acoustic and electromagnetic subsurface imaging has done, is give us the ability to see the places without entering them, to know they are there without yet knowing what is inside them, to have enough of the shape to understand, at least in outline, what we are dealing with, without yet having the physical evidence that would resolve the remaining questions. It is a very particular kind of knowing. It is like being able to read the outline of words in a sealed envelope without being able to open the envelope. The words are there. You know they are there. You can see enough of their shape to know they are words and not just marks. But their full meaning is still behind the seal, still waiting for the moment when someone, with the right preparation and the right intentions and the right combination of academic, governmental, and indigenous consent and oversight, puts a hand on the seal and carefully, respectfully, irreversibly opens it. That moment has not come, but the envelope is in the room, and everyone who knows it is there, is thinking about what it might say. The people who have come to know about the Canadian tunnel data are not a uniform group. They range from professional archaeologists and geologists who encountered the information through formal institutional channels, to independent researchers who pieced it together from public records, leaked documents, and conversations with people willing to speak on background, to indigenous knowledge keepers who were approached directly by researchers seeking to understand what the oral traditions might add to the interpretation of the scan data, to a small number of journalists who have been circling the story without yet finding the specific, on-record, institutional confirmation that the editorial standards of major publications require before they will publish something this significant. The edges of this community are defined by the current threshold of what can be verified and what cannot, and that threshold is moving slowly but perceptibly as more people engage with the data and as the informal review process generates more commentary from more specialists. Among the archaeologists, the response has been divided in a way that is predictable if you understand the disciplinary culture of North American archaeology. The older generation of senior academics, those whose careers were built on the Clovis First consensus and who have the deepest professional investment in the frameworks that consensus supports, have been the most resistant. Not uniformly resistant. Some have simply declined to engage with the data at all, citing the absence of peer-reviewed publication as grounds for withholding comment. Others have engaged but have argued with varying degrees of elaboration, that the scan data is ambiguous enough to support geological explanations that the review team may have dismissed too hastily, that the oral tradition correlations are speculative, that the historical fragments from construction records are too imprecise to be meaningful, and that the appropriate response is to wait for excavation before drawing any conclusions. These are the most conservative positions available within a scientific framework, and they are not dishonest positions. They reflect genuine standards of evidence that any serious researcher should apply to any claim of this magnitude. The middle generation of archaeologists, those who have built their careers in the post-Clovis environment, where the timeline has already been revised significantly and the pre-Clovis evidence base has grown substantially, have been more willing to engage. Several have privately indicated that the scan data, taken together with the oral tradition parallels and the historical fragments, constitutes what one described as the most intriguing anomalous dataset in Canadian archaeological contexts in the past decade. Most have also indicated that they are waiting for more information before making any public statement. The institutional cost of being associated with a claim that turns out to be wrong or that is accurate but premature is high in a small professional community where reputation is closely tied to the quality of one's evidential standards. The incentive to wait is strong. The personal motivation to engage is strong in the opposite direction. The result is a group of people who are watching very carefully and saying very little in public. The younger generation is different. The cohort of researchers who came of age in the period after the Amazon LiDAR discoveries, after the paradigm-shifting dates from Bluefish Caves and Monte Verde, after the genetic revelations about Denisovan introgression in Native American populations, after the complete collapse of the single migration model of American peopling, this generation does not have the same investment in the frameworks that the scan data challenges. They are doing archaeology in a landscape where the rules of the game have already changed significantly, where extraordinary antiquity and unexpected complexity are not theoretical possibilities, but documented realities in multiple sites across the hemisphere. For them, the Canadian tunnel data is not a paradigm challenge. It is a data point in an already significantly revised picture. Their engagement with it is more direct, their willingness to speculate more open, their impatience with institutional management of the information more visible. It is primarily from this younger generation that the public commentary on the scan data, such as it exists, has come. Blog posts and academic social media commentary and conference corridor conversations that have gradually widened the circle of people who know about the data, even as the formal institutional response remains cautious. This is how paradigm shifts move in academic communities. Not from the top down, from the edges in, from the people who have the least to lose by engaging with uncomfortable data, from the people who came to the field when the field was already changing, and who see further change not as threat but as opportunity. The Indigenous dimension of this situation is the most ethically significant and the most institutionally complicated. Any excavation of the tunnel network, if it is authorized, will necessarily take place on territory that has deep and complex relationships with Indigenous nations who were not consulted about the initial survey and who have not been systematically involved in the interpretation process thus far. The UN DRIP, the United Nations Declaration on the Rights of Indigenous Peoples, which Canada endorsed in 2016 and formally adopted into domestic law in 2021, establishes obligations around consultation and consent for activities that affect Indigenous peoples' cultural heritage. The tunnel network, if it represents what the scan data suggests, is cultural heritage of extraordinary significance to the nations whose oral traditions encode memory of it. Any investigation of the features needs to occur within a framework that honors those obligations and those relationships. The researchers who have been working most thoughtfully with this material have argued, consistently, that the investigation of the tunnel network cannot be conducted responsibly without the full, free, and prior informed consent of the relevant Indigenous nations, and that the interpretation of the findings cannot be conducted responsibly without the active participation of Indigenous knowledge keepers who can bring to the physical evidence the context that the oral traditions provide. This is not a tokenistic inclusion. It is a recognition that the two kinds of knowledge, the physical data from the scans and eventually from the excavation, and the oral and traditional knowledge from the communities whose ancestors knew this landscape, are complements rather than competitors. Neither one alone is sufficient to understand what the tunnel network is and what it means. Together, they offer the possibility of an interpretation that is richer and more accurate than either could produce in isolation. There are indigenous scholars and knowledge keepers who are actively engaged with this material on their own terms, not as subjects of outside research, but as principals in an inquiry that concerns their heritage and their history. Several have described their response to the scan data in terms that emphasize continuity rather than discovery. For them, the news that tunnels exist beneath the cities is not surprising. It is confirmation. It is the scientific validation of something that the oral traditions have been saying for a long time, something that outside researchers and governments have consistently declined to take seriously, precisely because it came from an oral tradition rather than from a written record or a physical survey. The scan data does not reveal something that was unknown. It reveals something that was known and not believed. That distinction matters enormously to the communities whose knowledge was not believed, and any investigation of the features needs to be conducted with a clear-eyed recognition of that history. The ethical framework for how to proceed is being worked out slowly, in conversations among indigenous nations, federal and provincial heritage agencies, the academic institutions involved in the review group, and the municipal governments under whose streets the features lie. These conversations are not public. They are not proceeding quickly. The institutional complexity of coordinating all of these parties with their different legal relationships to the territory and the heritage features and to each other is genuine and is not being used merely as a pretext for delay, though it may also be functioning as a convenient structural mechanism through which delay can occur without anyone needing to explicitly choose delay. The result, in either case, is the same. The features remain unseen. The chambers remain sealed. The objects on the chamber floors remain where they have been, for however long they have been there. I want to spend some time, before we move to the final part of this inquiry, with what it feels like to know about this situation from the inside of the research community, as reported by people who have been working with this data for months or years. Because the phenomenology of this kind of knowing, the experience of holding knowledge that is real and significant and contested, and institutionally suppressed in the sense of not yet publicly acknowledged, is something that shapes how the research proceeds and how the researchers experience their professional lives in ways that are not often talked about in the formal literature. One researcher described it as living in two parallel worlds. The world of normal academic life, where she attends conferences and publishes papers and teaches graduate students and reviews grant applications, and where the Canadian tunnel data does not exist, is not spoken of, is not part of the professional conversation in any formal sense, and a second world that is always present behind the first, a world where she knows that under the streets of Quebec City and Montreal there are sealed chambers with objects in them whose nature is unknown, connected by a tunnel network whose builders are unknown and whose age is unknown, Pisimalicos, in a landscape whose pre-contact history is apparently far more complex than the world she inhabits professionally will yet acknowledge. She said the two worlds coexist without collapsing into each other, that she has learned to move between them, but that there are moments when she is in the ordinary world and someone says something confident about what they know about Canadian prehistory, when the presence of the second world becomes almost unbearable, not in a dramatic way, just in the quiet way of knowing something that the official story does not include. Another researcher, the geologist whose specialty is subsurface mapping, and who came to the data through the formal review process, described his experience in terms of professional cognitive dissonance. He has spent his career working within a geological framework that describes the bedrock of the St. Lawrence region in ways that are inconsistent with what the scan data shows. He cannot reconcile the data with his models. He has spent considerable time trying to find natural explanations for the features that are geometrically consistent enough to be plausible, and he has not found them. He described the experience of looking at the scan data and knowing that it means something outside his professional framework as similar to what he imagined it might feel like to be a very skilled map reader who suddenly encounters a map, feature that corresponds to no known geography. You know the map is accurate. You know your map reading skills are good. but the geography the map is describing doesn't fit anything you know exists. He said that this feeling, which he had expected, would resolve as he spent more time with the data and found a natural explanation, has not resolved. The data keeps showing him the same thing, and the thing it keeps showing him is not geological. The acoustic specialist who wrote the communication about the surface treatment of the tunnel walls, the communication that was underemphasized in the preliminary report, and that one of her colleagues felt compelled to share more widely, described her experience in more personal terms. She said that what troubled her most was not the data itself, but what it implied about what has been missed. If a tunnel network of this scale can exist beneath two major Canadian cities and remain entirely unknown to modern archaeology until scans of this precision are deployed, what else is there? Not in some exotic location. Under streets that people walk every day, under buildings that have been occupied for centuries, under the ground that people plant gardens in and lay pipes through and excavate basements into. How many other structures, how many other sealed chambers, how many other objects placed somewhere by someone, for reasons that were important to them, are in the ground beneath ordinary places, invisible because the tools to see them have only just been invented. She said the thought had changed how she experienced ordinary urban spaces, that she now walks through cities thinking about what is under them in a way that she hadn't before, and that this is not an entirely comfortable way to move through the world. These are not naive researchers. They are not people prone to mystical thinking or credulous engagement with unverified claims. They are specialists in their fields who have spent their careers applying rigorous standards of evidence to difficult questions. Their discomfort with what the scan data is showing is not the discomfort of true believers who have found confirmation for something they always wanted to believe. It is the discomfort of empiricists who have found data that their empiricism obliges them to take seriously and that their frameworks are not prepared to accommodate. That is a specific kind of intellectual discomfort, and it is, in the long history of scientific progress, one of the most reliable signs that something real has been found. There is a philosopher of science named Thomas Kuhn who wrote, in the middle of the 20th century, about the structure of scientific revolutions. His central observation was that science does not progress primarily through the accumulation of confirming evidence for existing theories. It progresses through the accumulation of anomalies, findings that the existing theory cannot explain, until the anomalies become so numerous and so significant that the existing theory can no longer accommodate them, at which point the theory is replaced by a new one that can. He called this process a paradigm shift, and he observed that paradigm shifts are not smooth or comfortable. They involve resistance from those invested in the existing framework, institutional management of the anomalies, delay in acknowledgement, and eventually a reorganization of the entire field around the new understanding, at which point the new understanding seems so obvious that it is difficult to remember why it was resisted at all. The Canadian tunnel data is, by the standards of Kuhn's analysis, an anomaly of the kind that precedes a paradigm shift. It is not alone. It is part of an accumulating body of anomalies in North American archaeology that includes Monteverde and Paisley Caves and Bluefish Caves and the Cerruti Mastodon and the LiDAR revelations of the Amazon and dozens of other sites, and findings that individually are dismissible and collectively are not. The question of when the accumulation reaches the threshold that forces the paradigm shift is one that cannot be answered in advance, because the process is not linear and the threshold is not fixed. It is negotiated. It emerges from the dynamics of a professional community processing evidence it cannot fully accommodate. But the accumulation is happening, the anomalies are multiplying, and the Canadian tunnel data is one of the most specific, most geometrically clear, most independently corroborated of all of them. The world beneath the old cities is waiting. The machines have found it, the oral traditions remember it, the historical fragments have glimpsed it. The researchers know it is there. The indigenous nations whose ancestors knew it are watching what happens next. And what happens next is still, at this moment, undetermined, which means it is still, in the most important sense, open. Open in the way that all genuinely significant mysteries are open. Not open in the sense of unknowable, but open in the sense of not yet known. The difference between those two is the difference between giving up and continuing. And in the history of science, in the history of archaeology, In the history of every discovery that has ever changed what we thought we knew about who we are and where we came from, continuing has always been the answer. There is a specific kind of darkness that exists 42 meters below the surface of the Earth in a sealed limestone chamber. It is not the darkness of a room with the lights off, where the shapes of things are still present as the memory of light, still available to your eyes as they adjust. It is not even the darkness of a forest at night, where starlight and moonlight filter through leaves, and the darkness has gradations, near dark and far dark, and the pale suggestion of form. It is the darkness of zero photons, the darkness of a space where, for however long the chamber has been sealed, not a single particle of light has entered. The darkness that existed before any eye evolved to register the absence of it. In that kind of darkness, temperature equalizes. The rock settles to the mean temperature of the ground at that depth, which in this region of Canada is somewhere between 6 and 8 degrees Celsius year-round, cold enough to preserve, steady enough to protect, consistent enough to maintain whatever has been placed there against the biological processes of decay that require warmth and oxygen, and the biological agents that cannot survive without them. Whatever is in that chamber has been in that darkness, in that cold, for a very long time. Long enough that no one alive remembers it being placed there. Long enough that the memory of it, if it survived at all, survived only in the compressed and symbolic form of oral tradition, in the names and the stories and the fragments of geographic knowledge that have crossed the centuries from the time of the placement to the time of the scan. Long enough that the tunnel network that connects that chamber to the surface was itself forgotten, or remembered only in the generalized way that the oral traditions describe, as the beneath places, as the world inside the rock. Long enough that when the scanning machines sent their acoustic pulses into the ground, and the pulses came back with the shape of the chamber and the object at its center, the people in the survey van looking at the data returns did not know what they were seeing. They knew they were seeing something real. They knew the data was not instrument error or geological artifact, but they did not have a framework for what it meant, because the framework that would have let them understand it immediately is exactly the framework that the discovery, if it is what the evidence suggests, will eventually require to be built. Building frameworks is slow work. It is slower than digging tunnels, slower than placing objects in chambers, slower, often, than the things that make the framework necessary would want it to be. The builders of the tunnel network, whoever they were, built something in stone that has lasted for what may be thousands of years. The framework for understanding what they built is still under construction. It is being assembled, piece by piece, from acoustic data and cast analysis and oral tradition and historical fragments and the careful, cautious, intermittently frustrated communications of a small group of specialists who know more than they can yet say publicly. The framework will be finished before the tunnel is entered, or it will be finished in the process of entering, or it will be finished after, but it will be finished, because this is how knowledge works. It accumulates until the weight of it becomes undeniable, and then it reorganizes, and then the new shape of what is known becomes the basis for the next set of questions, and the questions begin again. The questions begin again. That is the part I want to stay with for a moment, because it is the part that this story shares with every genuinely significant mystery in the history of human self-understanding. The questions do not end, they transform. The answer to one question opens 3 more. The resolution of one anomaly reveals the edges of 3 larger ones. The excavation of one sealed chamber, when it finally happens, will answer some things that the scan data cannot answer: what the objects are, what they are made of, what period they can be dated to, what material was applied to the walls and for what purpose, what the floor is made of, and what was done on it. And those answers will open questions that are currently impossible to ask, because the information that would make them possible does not yet exist. Questions about the relationship between this tunnel network and other subsurface features elsewhere in North America. Questions about the cultural relationships between the builders and the people who came after them. Questions about what the objects in the chamber were intended to do, whether they were tools or records or offerings or something for which no existing category is adequate. Questions about what we are still missing, about what is still in the ground beneath other old cities, other old landscapes, other places where the scans have not yet been deployed and the oral traditions have not yet been asked. The history of archaeology in the Americas is full of things that were in the ground before anyone thought to look for them. Every significant pre-Columbian site that has been excavated in the past century was, before its excavation, either a surface feature whose significance was not understood, or a subsurface feature whose existence was entirely unknown. The people living on or near those sites for the centuries before their excavation did not see what was in the ground beneath them. Sometimes they suspected. Sometimes the oral traditions of nearby communities preserved fragments of relevant memory, but the full picture was only available through excavation. The tunnel network beneath the street, Lawrence Valley cities, is in the same relationship to the present moment that every one of those significant pre-Columbian sites was in before its investigation. It is there. It is real. Its significance, once confirmed through direct investigation, will reorganize what is known. The investigation has not happened. The reorganization has not happened, but both are, in the logic of this situation, inevitable. What makes this situation unusual, and what makes it feel different from the discovery of any surface site, is the depth, 42 meters of solid rock. The tunnel network and its chambers are not sites that will be reached by the casual shovel of a construction worker or the systematic trenching of a standard archaeological survey. They require specific intent, specific technology, and specific authorization to reach. They are protected by their depth in a way that no surface or near-surface site is protected. Nothing that has happened on the surface of the Canadian landscape in the centuries since the network was sealed has reached it. The colonial settlement did not reach it. The industrial development did not reach it. The municipal infrastructure expansion did not reach it. 42 meters of rock is a very effective vault. Whatever is inside the vault has survived everything that has happened above it, not because it was defended or hidden in any active sense, but because the depth itself is defense. The patience of stone is greater than the patience of any human institution. I want to say something about patience, because this story requires it. The story of what is in the ground beneath Quebec City and Montreal and the Northern Survey Zone is a story that will not be fully told in any near future. The investigation, when it is authorized, will take years. The analysis of the findings will take years more. The synthesis of the physical evidence with the oral traditions and the historical record, the genuine interdisciplinary work of building the framework within which the findings make sense, will take longer still. This is not a story that will be resolved by next year, or the year after, or possibly in any decade foreseeable from this vantage point. It is a story that is beginning. The scan data marks the beginning of a process whose middle and end are not yet visible, and that beginning is worth sitting with. Because the beginning of an important story, the moment when something hidden starts to become visible, when the tools finally arrive that are sensitive enough to detect what was always there, is a moment with its own particular quality. It is a moment of opening, of possibility, of the world being suddenly larger than it was before the opening, of the past being suddenly richer, deeper, more complicated, and more interesting than the frameworks that preceded the opening were able to contain. Every time this happens, in the history of archaeology, in the history of science, in the history of any field that studies what has been rather than what is, the world that results from the opening is bigger, not necessarily more comfortable, not necessarily simpler, but bigger, more adequate to the actual complexity of the thing it is trying to understand, more honest about the scale of what remains unknown. The world that will result from the opening of the Canadian tunnel network, when it finally happens, will be bigger than the world of Canadian and North American prehistory that currently exists. It will have more in it. More people who were in this landscape, doing things that left permanent traces before the things that history records began. More engineering, more organizational complexity, more cultural sophistication, more depth to the story of what it means to be human in this part of the world. More connections between the physical evidence and the oral traditions. More respect for what the oral traditions have been preserving, in their fragmented and sometimes cryptic way, across the centuries since the builders went away. More questions, more openings, more beginnings. Consider for a moment the experience of the first researchers to review the scan data, sitting in whatever conference room or office or university lab the data was first examined in. Looking at a screen showing acoustic returns from below the streets of a city they had walked through dozens or hundreds of times, watching the images resolve into shapes that had no place in the world they were trained to understand. The consistent bore diameter, the chamber expansions, the branches toward the river, the object at the center of the terminal chamber floor. That experience of looking at something that should not be there, that is there, that the machines have found and that the instruments have confirmed is real, is an experience that changes a person, not dramatically, necessarily, not in a single moment of revelation, but steadily over the time that follows, as the implications accumulate and the conversations with other specialists begin, and the oral tradition parallels are established, and the historical fragments are assembled, and the shape of the thing gradually becomes visible. That change is not reversible. You cannot unsee what the scan data shows. You cannot unknow what the acoustic specialist wrote in her communication about the wall surfaces. You cannot unhear what the Wendat elder said about the people who were there before everyone she could name. What you can do is hold it carefully. Continue to hold the standard of evidence. Continue to require physical confirmation. Continue to insist on the rigor that separates legitimate investigation from wishful thinking. But hold all of that alongside the knowledge that something is there, and that what it means is not yet known, and that not knowing yet is not the same as never knowing. The tunnel is there, the chambers are there, the objects are there, the oral traditions are there. The oral traditions were always there, and the ground is waiting, as ground always waits, with the infinite patience of rock, for the moment when human beings, with all their complexity and their disagreements, and their institutional cautions, and their ethical obligations, and their competing frameworks, and their genuine curiosity about where they came from, decide to go in. The first light in that chamber, when it finally comes, will be the first light to enter it, in a period of time that none of the people holding the light will be able to precisely specify. The first light in a space that was sealed in a darkness that has not been broken since before the French called the promontory Quebec, and before the Algonquin called it Quebec, and before whatever name it had before that. In whatever language the people who built the tunnel beneath it spoke, when they sealed the chamber and left and did not come back. The light will move across the walls and show the surface treatment that the acoustic data could only characterize as denser than native limestone. It will illuminate the floor and reveal whether it is as level as the scan data suggests. It will reach the center of the chamber and fall on whatever is there, and the people holding the light will see it, and they will know, for the first time, what shape the object takes, what material it is made of, whether it is single or compound, whole or damaged, alone or accompanied by things too small for the acoustic return to resolve. And then the work of understanding will begin, again. As it always begins again, when the light reaches a new place for the first time. As it has begun again at every cave painting site, and every burial mound, and every drowned coastal settlement, and every ancient city revealed by a satellite image of a drought-dried plain. As it will begin again, when the time comes, in the cold quiet of a chamber 42 meters below the streets of Quebec City, where something has been waiting, in the particular darkness of 0 photons, for longer than any of us currently knows. The tunnel network is there. The questions it is asking of us are real. The patience of stone is greater than the patience of institutions, but not, in the end, greater than the patience of curiosity. And human curiosity, in the long history of the species, has always outlasted everything that tried to keep it from the dark places. That is one of the things we know about ourselves, one of the oldest things. One of the things the builders of the tunnel might have known as well, if they left what they left with any thought for who might eventually find it. Perhaps they did leave it for someone to find. Perhaps the objects in the sealed chambers are not remnants of use, but deliberate deposits, not things abandoned, but things placed, not lost but hidden, in the way that some things are hidden, in the hope that the right seeker will eventually arrive. Perhaps the sealing of the chambers was not the end of the story, but a pause in it, a very long pause. A pause that has now lasted long enough that the pause itself has become the story, has become what we are talking about, has become the thing the machines have found, and the thing the oral traditions have been keeping, and the thing the institutions are cautiously managing, and the thing the researchers are holding carefully, and the thing the elder was waiting to be asked about. Perhaps. We do not know. We do not know enough yet to know, but we know something. We know the shape of the tunnels. We know the temperature of the chambers. We know the density of what the acoustic data reads as objects on the chamber floors. We know that the karst geomorphologist said it cannot be geological. We know that the retired geologist said it looks purposeful. We know that the Wendat elder said the passages were built by someone who was there before everyone she could name. We know that 2 oral traditions from 2 different nations describe builders of underground spaces in this landscape in terms consistent with what the scan data is revealing. We know that the standard narrative of North American prehistory is less adequate to the actual complexity of the past than it has been presented as being. We know that the ground holds things that the ground has not yet given up. This is not nothing. In fact, if you sit with it long enough, it is quite a lot. It is the beginning of a different story. Not the story that we have been telling about this part of the world. A different one, older, deeper, more honest about how much we do not know and how much the people who came before us, in ways we do not yet understand, knew. The story of what is in the ground beneath Canada's oldest cities is a story that has been waiting for a very long time to be told. The machines have made a beginning. The telling has begun. Where it ends is not yet known, which means, in the best possible sense of the word, that we are only at the beginning. If you are still awake, or if you are drifting now on the edge of sleep, listening to this story settle into the quiet of wherever you are, I want you to think about the patience of stone, not as a metaphor, as a literal fact. The rock beneath Quebec City has been there for 450 million years. The tunnel cut through it may have been there for 10,000. The things in the sealed chamber may have been there for a portion of that time that is, by any human measure, very long, and they are still there. They have not moved. They have not degraded in the cold and the dark. They are waiting with the patience of things that have no urgency, because urgency is a quality of living things, and stone and sealed darkness have no life in them, only persistence, only the extraordinary passive endurance of things that remain, while everything around them changes. The cities built up above the tunnels. They grew and burned, and were rebuilt, and were fought over, and changed hands, and grew again, and filled with people and traffic and noise, and the accumulated weight of 400 years of colonial and post-colonial urban history. And below all of it, unchanged, unaware, incapable of the awareness that would allow it to care about being unchanged, the tunnel waited, the chambers waited, the objects waited, the surface treatment on the walls waited, the level floor waited. The object at the center of the terminal chamber waited with the patience of something that was placed there intentionally and has had nothing but time since. And now the machines have arrived, and the machines have looked, and the machines have found what is there. And the people looking at the machine's findings are slowly, carefully, cautiously beginning to understand what it means. And the story is beginning. And the beginning is enough. For now, for tonight, in the quiet and the dark, the beginning is enough. The ground is speaking. The elder said it would. In the language of acoustic waves and sensor returns, and scan data shared in careful documents among specialists who are not yet ready to say publicly what they are ready to think privately, the ground is speaking. It is saying, in the patient vocabulary of deep time, that it has been here longer than the cities, that it was here before the colonial period, and before the pre-contact period, and before any name that anyone living still remembers was the name for this landscape. It is saying that it contains what it contains, and that what it contains is real, and is old, and is waiting, and has a story, and that the story is not over, it is just beginning to be heard. Wherever you are right now, whatever city is above you, or whatever countryside surrounds you, the ground beneath you also has a depth, also has a history, also contains things placed or formed or shaped by time and intention, and the forces that work on stone over periods of time that human lives cannot directly comprehend but human curiosity can gesture toward, can try to understand, can hold with the same patience that the stone itself holds the things sealed within it. The world is very old, we are very new, and the space between those two facts, the space that the tunnel network occupies, the space that the sealed chambers hold, the space between the oldest things and our current capacity to see them, is the space where the most interesting questions live, the ones that have not yet been answered, the ones that are still forming, the ones that the machines have only just begun to ask. Rest now, if rest is coming. Let the story settle. Let the image of the tunnel hold itself in the way that quiet images hold themselves in the moments before sleep, vivid and then less vivid and then present as something felt rather than seen. The rock is there. The chambers are there. The objects are there. The questions are there. And somewhere, in the offices and field camps and university labs and community meetings of the people who are working on this, carefully and slowly, and with the seriousness that the evidence demands, the answers are forming. Not yet visible, but forming, the way anything forms in the dark, with patience and time and the accumulated weight of what is already known, pressing steadily toward what is not. Good night. The ground beneath you is older than you are, and it has not forgotten a thing. There is a particular quality to the relationship between a landscape and the people who have lived in it long enough to build into its rock. It is not a relationship of ownership in any legal sense. It is something older than ownership, something that develops when generations of people learn a place so thoroughly that the place becomes part of the vocabulary through which they think, the way that a first language is not just a communication system, but a lens that shapes perception at a level below conscious choice. The builders of the tunnel network, whatever their name, whatever their language, whatever the specific cultural content of the tradition within which they built, had that kind of relationship with the limestone of the St. Cio's, Lawrence Promontory, and the granite of the Shield. They were not working in unfamiliar material. They were working in the substance of their home. And that intimacy with the material is probably part of what made the tunnel possible. You do not cut through 40 meters of rock, without knowing the specific rock you are cutting, without knowing where it is weaker and where it is stronger, which fractures run in what directions, where the water moves through it and where it is dry, what sounds it makes under different kinds of percussion, how it responds to heat and cold and sustained application of force. This is knowledge that accumulates over generations of close attention to a specific place. It is geological knowledge, but not in the academic sense. It is the geological knowledge of people for whom the rock is not a dataset, but a neighbor, an intimate, something known the way you know a person you have lived beside for your whole life, and your parents lived beside before you and their parents before them. The oral traditions that encode memory of the tunnel builders are not the only bodies of knowledge that might illuminate who they were. There is a field of scholarship called archaeolinguistics that uses the comparison of living languages and their reconstructed ancestral forms to trace the movements and relationships of the peoples who spoke them. The languages of the St. Lawrence region, including the Haudenosaunee languages, the Algonquin languages, and the now extinct Laurentian language that Jacques Cartier encountered in the 1530s and that disappeared before any significant documentation could be made of it, all belong to lineages whose relationships to each other and to the larger families of North American languages have been the subject of extensive scholarly work. The Laurentian language is of particular interest in this context because it was spoken by the people who were living in the St. Lawrence Valley when the first European documentation of the region was produced, and because it disappeared so completely that linguists have been unable to confidently assign it to any known language family. Cartier's word lists from the 1530s, which are the only significant documentation of the language, show some similarities to the Iroquoian languages of the Haudenosaunee, but also contain elements that are difficult to account for within the Iroquoian family. The Laurentian people were described by Cartier as agricultural, living in substantial villages with longhouses similar to, but not identical to, the Haudenosaunee longhouse tradition, and they were gone by the time Champlain arrived in the early 17th century, replaced or absorbed or displaced by a population shift that the historical record notes, but does not explain. The timing of the Laurentian disappearance, sometime in the second half of the 16th century, is interesting in the context of the tunnel data because it represents a disruption in the human landscape of the St. Lawrence Valley at precisely the period when the first European documentation of that landscape was being produced. If any living knowledge of the tunnel network was held by the Laurentian people, it would have been lost or transferred to other communities at exactly the moment when European observers were first present to record it. The absence of any European account of the tunnels may therefore not reflect their absence from indigenous awareness, but rather the specific timing of the Laurentian disappearance relative to the beginning of the European documentary record. The people who might have known to tell the Europeans about the tunnels were gone before the Europeans had been there long enough to ask the right questions. The archaeolinguistic thread connects to a broader set of questions about pre-contact population dynamics in the St. Lawrence Valley, that are themselves only partially resolved in the current literature. The valley is, and presumably was, a major corridor of human movement, a highway in the geographic sense that channeled movement and interaction between the interior of the continent and the coast in ways that would have produced complex patterns of contact, exchange, displacement, and cultural mixing over the long period of human presence in the region. The tunnel network, if it served as a movement corridor parallel to the river surface, would have been integrated into these dynamics in ways that may have been strategically significant. Control of a hidden river access point and a subsurface movement corridor in a geography where the surface river was the primary highway of travel could have had enormous implications for the political and social relationships among the pays, peoples moving through and living in this landscape. It is not necessary to posit any specific scenario. It is sufficient to recognize that the tunnel network, whatever it was built for initially, would have been a resource of significant potential value to any community aware of it during the long period of its use. The question of how long it was in active use is distinct from the question of how old it is. A structure can be built in one period and used across a much longer period by the same community or by successive communities. The Kharez systems of Iran, some of which are 2,000 or more years old, continue to be used today by farming communities who maintain them using knowledge that has been transmitted continuously since their construction. The use of a structure does not require continuous, unbroken transmission of detailed knowledge about its construction. It requires only that the structure remain functional and that each generation that uses it teaches the next where it is, how to enter it, and what it is for. The tunnel network may have been in continuous use from its construction until relatively recently in the pre-contact period, with the knowledge of its existence held by specific lineages or specialist groups within the communities that used it. The disruptions of the contact period and the subsequent colonial period would then have been what severed the practical knowledge of the network's existence from its physical reality, leaving only the fragmented oral tradition references that researchers are now attempting to reconnect to the physical evidence the scans are revealing. In the comparative literature of underground heritage sites around the world, the pattern of long use, community-transmitted knowledge, followed by disruption and the reduction of knowledge to fragmentary oral tradition is not unusual. The cave systems of southern France, which served as ritual and habitation sites for Ice Age peoples, and which were eventually sealed by roof collapses and sediment infilling, preserved the knowledge of their existence in local folk traditions and myths for thousands of years after they ceased to be physically accessible, until the intersection of the folk memory with the chance discoveries of modern times, in cases like Lascaux and Chauvet, reunited the tradition with the physical reality. The same pattern, on a different scale and in a different cultural context, may be what the Canadian tunnel data is representing. The folk memory is in the oral traditions. The physical reality is in the scan data. The reunion of the two is beginning. The material evidence that the excavation might eventually reveal is worth imagining in some detail, because the imagination of it is part of what drives the inquiry forward and part of what gives this story its particular quality of sustained suspense. The objects in the sealed chambers are the most compelling unknowns. In the existing literature of pre-contact North American material culture, the range of objects that would have been significant enough to place in a sealed chamber is actually not unlimited. Caches of significant material, items of trade value, or ceremonial significance, or technical importance, have been found at many archaeological sites across the continent. Copper objects, which the Great Lakes mining tradition produced in extraordinary quantities over a period of at least 6,000 years. Chert and obsidian toolkits, caches of prepared blanks, and finished tools representing the investment of significant skilled labor. Ceramic vessels of the types associated with various pre-contact traditions of the Eastern Woodland and Great Plains regions. Shell beads and gorgets, which have been found in pre-contact contexts as far as 1,000 miles from the Gulf Coast where the shells originated, testament to the reach of pre-contact trade networks. Red ochre caches, which appear at many sites across North America and which clearly held ceremonial significance across many different cultural traditions. Any of these categories of material could plausibly be what the acoustic scan is reading as objects on the chamber floors. But the acoustic data characterizes the primary object in the northern terminus chamber, as significantly denser than the surrounding limestone, denser than any of the common organic or lithic materials in the pre-contact material culture repertoire. Copper is denser than limestone, so is iron, though pre-contact iron use in the St. Lawrence region is not documented. So are certain mineral concretions that can form in limestone environments and that might be read by acoustic scanning as discrete objects rather than geological formations. The density signature does not narrow the possibilities to a single material, but it does raise the intriguing possibility that what the acoustic scan is detecting is metallic. The Great Lakes copper tradition is extensive, ancient, and produced objects of significant size from native copper, including axes, knives, projectile points, awls, and ornamental plates, some of which have been found in burial and cache contexts well to the east of the primary copper deposits. A large copper object, or a collection of copper objects cached together, would produce exactly the kind of dense, discrete, anomalous acoustic return that the scan data is showing. Copper objects in a sealed limestone chamber, in a tunnel network of this apparent antiquity, in a landscape where the oral traditions speak of ancient builders and beneath places, would be an archaeological find of staggering significance. Not because copper objects are rare in the pre-contact material culture of the region, they are not. They appear at dozens of sites, but because the context, the sealed tunnel chamber, the depth, the tunnel network itself, would provide a temporal and cultural context for the objects that no surface or near-surface cache has been able to provide. Objects in context are worth immeasurably more to archaeological interpretation than objects without context. A copper axe on a museum shelf tells you something. A copper axe in a sealed chamber at the end of a 3-kilometer tunnel system 42 meters below the surface of Cap Diamant tells you the beginning of a story you have never heard before. I want to return, in these final moments, to the idea of what it means to find something that has been hidden for a very long time. Not in the dramatic Indiana Jones sense, with booby traps and dramatic reveals and the sudden flooding of a crypt with torchlight. In the quieter, stranger, more honest sense of what actually happens when human beings encounter evidence of other human beings who were in the same places, living lives of comparable complexity and comparable intelligence and comparable concern for the things that seemed important to them, and who left something behind that survived them. The emotion that researchers describe when this happens is not primarily excitement, though excitement is present. It is something more like recognition, the recognition of continuity, of the thread. That, 10, of the fact that the people who made and placed and sealed whatever is in the tunnel chambers were not fundamentally different from the people who are now scanning the ground above them and reviewing the data and writing the communications, that their colleagues share carefully and privately, and, with a certain held-breath quality that reflects how significant they know this to be. The builders of the tunnel had intentions, they had purposes, they had things they wanted to preserve or achieve or communicate or protect. They had, almost certainly, some thought for the possibility that what they built might outlast them. Stone is the material of permanence in human cultural practice across the world and across time. People build in stone when they are building for a duration beyond their own lifetimes, when they want something to last. When the intention is not just for now but for later, the later has arrived. It took longer than perhaps anyone who sealed the chambers anticipated. Much longer, but the later has arrived, and the sealed chambers are still there, and what is in them is still there, and the people who built the machines that found them are now standing outside the seal asking what is inside. The answers to that question, when they finally come, will add something to the human story of this part of the world that is missing from it now. They will add depth. They will add time. They will add the presence of people who were here and built and lived and thought and placed significance in the rock and sealed it away and departed, and whose departure was sufficiently complete that almost no trace of them survived in any form recognizable to the peoples and cultures that came after them, except in the oral traditions that encode, in their compressed and symbolic way, the memory that they had existed. The stone carvers, the people who go inside the rock, the elder builders, they are names for something real, something that the scanning machines are now confirming was real, in the most literal possible sense. The names have been waiting for the thing they name. The thing has been waiting for the names. The reunion is not yet complete, but it is beginning. And beginnings, in the long history of what human beings have learned about the world they live in and the story of who they are the most important moments. Not because they determine outcomes, which they never fully do, but because they establish directions. The direction this beginning is establishing is toward a fuller, more honest, more complex account of what happened in North America before the things that history records began. An account that includes the stone carvers, that includes the beneath places, that includes the particular darkness of sealed chambers in limestone rock 42 meters below the streets of a city that has no idea what it is built on top of. An account that is, in the end, a better account, not better in the sense of more comfortable, better in the sense of truer, in the sense of closer to what actually happened in the long time before writing, and before cities and before any framework that currently exists to describe what the people of this continent were doing and building and knowing and preserving in the stone. The stone knows, the ground knows, the machines have begun to ask. The answers are coming, not tonight, not soon, but they are coming, with the slow certainty of things that have already happened and are only waiting to be recognized. The tunnel is there, the chambers are there, the objects are there. The story is there, sealed in the particular darkness of deep rock, patient with the patience of something that does not need to be told. It only needs to be found. And the finding has begun. Rest now. Let the story move through you the way all old stories move through us when we let them. Not as information to be retained, but as presence to be felt. The presence of people who were here before us, who built into the rock beneath the places we have built over them, who left something behind that has survived everything. That is still there. That is waiting, with infinite patience, in the cold and the dark, for the light that is coming, however slowly, however carefully, however complicated, the path to it turns out to be. The light is coming. It always comes in the end, to the places that have been waiting long enough. And few places have been waiting, as long as what the scan data found beneath Canada's oldest cities. Few places have been waiting with quite such patience, quite such completeness, quite such an absolute certainty that they will still be there when the waiting is done. The ground does not doubt itself. The sealed chamber does not wonder whether it is real. It is, and it waits, and that is enough. For now, for tonight, for the long quiet hours between this moment and the moment when the light finally arrives, that is enough. There is one final thread in this story that I have not yet fully pulled. It is the thread that connects what the Canadian scan data is showing to what other subsurface investigations in other parts of North America have been producing over the same period, and that suggests the tunnel network beneath the street. Lawrence cities may not be an isolated phenomenon, but a regional feature of a larger pattern that is only now becoming visible as the scanning technology becomes widely enough deployed to reveal it. This thread is the most speculative of all the threads in this inquiry, but it is also the most important for understanding what the Canadian data might ultimately mean in the broadest possible context. In the years since ground-penetrating radar became sensitive enough and portable enough to deploy in systematic archaeological survey, a small number of researchers working independently across different parts of North America have reported subsurface anomalies that share certain characteristics with the Canadian tunnel data, not identical, not obviously connected, but sharing the quality of being inconsistent with natural geological processes and potentially consistent with artificial modification of the subsurface. In the Ohio River Valley, where the Hopewell tradition built its remarkable network of earthworks between roughly 2,000 and 1,500 years ago, subsurface surveys around several of the major earthwork complexes have returned acoustic and electromagnetic anomalies at depths below the earthworks themselves that have not been followed up or published in any systematic way. The anomalies are deeper than any known construction feature of the Hopewell tradition. They are at depths consistent with the Canadian tunnel features relative to the surface at those locations. They have not been excavated, and they have not been the subject of any official investigation. In the Appalachian region of the eastern United States, where karst processes are well developed in the limestone formations of Virginia, West Virginia, and Tennessee, subsurface surveys, conducted for unrelated geological purposes over the past decade, have in several locations returned features that the survey teams characterized as anomalous, not karst in origin, located at depths, and with geometries inconsistent with natural dissolution. In at least 3 of these instances, the anomalous features are in geographic proximity to locations that indigenous oral traditions of the region describe as entrances to underground worlds, as passages to beneath places, as the dwelling places of the people who were here before the nations currently living in those landscapes. The same pattern, the oral tradition, in proximity to the scan anomaly. The scan anomaly inconsistent with geological explanation. The physical investigation not yet conducted. I am not suggesting that all of these features are connected. I am not suggesting that the tunnel network beneath Quebec City is part of a continental network of underground passages, though that possibility has been raised by some of the more speculative commentators on this material and cannot be entirely dismissed given the current state of evidence. What I am suggesting is that the Canadian tunnel data is not, in the global context of subsurface anomaly research, an isolated finding. It is the best documented and most thoroughly analysed example of a category of finding that is appearing in multiple locations across North America, as the technology to detect such features becomes more widely deployed. The pattern of that finding, subsurface features of apparent artificial origin in proximity to indigenous oral traditions of underground passage and ancient builders, is consistent enough across multiple independent investigations to suggest that whatever was happening in the pre-contact landscape of this continent, whatever the stone carvers and the elder builders and the people who go inside the rock were doing, it was not happening in one place alone. The full scale of what may be waiting in the ground across North America, waiting with the patience of things sealed in stone and maintained in tradition, is not something that any single investigation, including the one the Canadian scan data has initiated, can reveal. It will take time, it will take technology, it will take the slow, careful, respectful, interdisciplinary work of researchers who are willing to take the oral traditions seriously, and the scan data seriously, and the historical fragments seriously all at once, without privileging any one kind of knowledge over the others, without allowing any single institutional framework to determine in advance what can and cannot be found. It will take, above all, the kind of sustained curiosity that does not require immediate resolution, that can hold the open question without filling it prematurely with an easy answer, that can live with the particular intellectual tension of knowing that something is there without yet knowing what it is. That kind of curiosity is not common, but it is not rare. You are practicing it right now, in the small hours, in the quiet, listening to a story about something that is real and unexplained, and waiting in the dark under the streets of cities that were built without any knowledge of what they were being built on top of. The tunnel is there, the chambers are sealed, the objects are on the chamber floors, the oral traditions remember, the machines have begun to speak the language of the rock. And the conversation that is beginning between the technology and the tradition and the physical reality of what the ground contains is a conversation that will take a long time to complete, and that will, when it is complete, add something fundamental to what we know about the long, complicated, astonishing story of human beings in this part of the world. The beginning of that conversation is something worth having been awake for, worth having stayed with through the long, careful accumulation of evidence and context and implication and question that this story requires. The tunnel is there, and now, having come this far together, in the dark and the quiet, so are you. The winter in Quebec City is a particular kind of cold, not just cold in the meteorological sense, though the meteorological cold is real and significant, temperatures dropping to -20 and beyond, for weeks at a stretch, the river freezing solid enough in some years that horse-drawn sleighs could cross it. But cold in the historical sense as well, cold in the way that a place is cold when you know it has been lived in through winters beyond counting, when every season of snow has been endured by someone who did not have heated buildings or synthetic insulation or the ability to call for help if the cold became more than they could manage. The cold is part of the landscape the way the rock is part of the landscape. It is a condition of the place, a defining feature, something that every person who has lived here in any period has had to negotiate with and plan for and find ways to survive. The tunnel network is, among other things, a response to cold, a response to the specific, demanding, relentless cold of the street, Lawrence winter, and the need of the people who lived in this landscape to find ways of moving and storing and protecting themselves and their things during a season that the surface landscape made extremely hostile. Below 4 meters of ground, in the bedrock of this region, temperature is essentially constant year-round. Not comfortable constant, not living room warm, but above freezing, which is the critical threshold. A space that is consistently above freezing in the deepest winter is a space where food can be stored without freezing solid, where water can be maintained liquid, where a person sheltering from the surface conditions can survive in ways that would not be possible if exposed to the ambient temperature above. The practical value of the tunnel network as cold weather infrastructure for any community operating in this landscape in any period is enormous. It is worth thinking about this not as an ancient mystery, but as a very practical solution to a very practical problem that every community in this landscape has always faced. The cold was the constant, the tunnel was the response, and the response worked for however long it was in use, because it was built in the one material that the cold of Quebec cannot reach: rock, deep rock. The patient, constant, cold-proof rock that the scanning machines have now confirmed contains exactly what the oral traditions and the historical fragments and the professional judgments of the geologist and the karst specialist have been pointing toward, each in their own language, each from their own angle, each with their own incomplete piece of the same picture that the tunnel network, when it is finally entered and its story is finally told, will put together in the only way that matters, completely, from the inside. In the light, the ice above the tunnel has melted every spring for 10,000 years or more. The river has run high and run low. The forests have grown and burned and grown again. The peoples of this land have lived through everything the climate of this place could produce. And below all of it, unchanged by any of it, the tunnel has waited. That is the final thing to carry into sleep. Not the mystery, though the mystery is real. Not the questions, though the questions are important. But the patience. The extraordinary, inhuman, geological patience of something built into the permanent substance of the earth and left there for whoever came next, for however long it took, for the particular future moment when the technology and the tradition and the will and the questions would all arrive together at the same place. That moment is now, or close to now, and the patience of the tunnel, which has already waited longer than any of us can fully comprehend, can certainly wait a little longer for what comes next.